All right, hello and welcome everyone. We're gonna do, excuse me, we're gonna do a Friday Twitter community space. Join Nick Cage and the boys and see what everyone's up to.
And into attacking us because they were fighting China, who was also communist, and they were winning. And had they won, they would have attacked Russia from the east, but they didn't do that, and they were able to take troops and go fortify Stalingrad and make a big victory over there, which was a turning point in the war. All right, and then as Berlin was getting ready to fall, Russia was promised Berlin. They were also promised all of the rockets and shit. Well, they said, we're pissed off about that because we wanted them. Why they decided to go with the space race? Couldn't tell you. Why Russia is bankrupt? I don't know. They suck at money management. I guess. I mean, we pay our taxes and we're $37 trillion in debt. So I don't know how finances work and how countries go broke. I don't know how we have a $37 trillion debt. So, I mean, why they went bankrupt, I can't tell you that. But I want to tell you this for the third time. Russia and America have never been enemies. All right, they signed an Antarctica treaty. They don't break that. And they also put dudes up in an ISS together. And they don't fight up there either. Are
Dude,
we
remember
clear on
that?
that?
Remember that time they almost fought, bro?
You're bringing three different topics and three different fucking generations. You're going back to 1940. You're going back to 1950, and I'm not
Yeah,
talking
I'm
about that.
giving
And
you
nor
a
that I did.
history. I'm giving you a history on why they are not enemies. We are not enemies, but friends. As you stated, you thought they were mortal enemies when they were just kind of more like, you asshole kind of thing. They're
Uh,
friends that, they got pissed off at each other. They had a little spat. You understand? They're not mortal enemies. Have you ever, can you tell me one war, one battle that we had with Russia?
It's not. It's not a matter. Well, you could go back to the Cold War,
Dude,
but
this is a point I'm trying to make.
the
There was
Cold
never
War.
a war
So
with
it was a
Russia.
proxy war. The Cold War was
Dude,
a
it was
proxy
called
war.
a Cold War. There was never a
Yeah,
battle.
I said that.
It was
I'm the one
all
that.
fakery. What part of that aren't you getting?
Look,
I think it just
you're.
comes down to the fact that he's got this in his mind, and you've got to prove that they weren't mortal enemies. I gave him Russian cosmonauts, Soviet cosmonauts that said we've never been to space. If anybody tells you they have been to space, they're not telling you the truth. And another one that said, yeah, the Earth is flat. I didn't expect that question, but I assure you it's flat. So you have the Soviet cosmonauts that are putting the lie to what was told before by the Soviet Union. So if that's not good enough, then hey, go go.
No, but
But
that's fine.
we have,
That's fine. Look,
yeah.
the whole point of public discourse and argument and debate is you have one opinion, I have the opposite opinion. That's okay, but that's okay. And I respect the opinion that you have. I respect, and you should also respect the opinion I have. And I do not
Well,
think
your
the world is
opinion's kind of
flat.
not really based off anything, though.
But if your
And
opinion is
also,
stupid,
then
then like,
also at the end of there, I threw in gas pressure laws
But I
to
think
block
your
that
opinion is
too.
stupid, so it's not going to work. Like it's not going to
How?
work.
Well, so okay, hang on.
Well,
What
hold on a
am
minute,
I
hold on a
just
minute, guys, hold on a minute,
totally?
guys,
Hold
hold on.
on,
Wait,
hold on, hold on.
Wait, do you think that what the story I told you was an opinion?
I think the story you told me was very well educated and very articulate, and I'm glad you told me. But I completely disagree with everything you said. But which is okay. Which is
So you
okay
think I'm a
because
storyteller? You
Yo,
don't
no.
wait,
think that you
yo,
don't
wait,
think
wait,
that
wait,
we
But
wait.
made
hold on,
eleven
Nick.
point
But
two
you're going to
billion
think
Hold
dollars
I'm
in
a
on.
Russia?
storyteller as well.
I've
Because if I have a different opinion than you,
Bro,
you're going to think
hold
that
on
I'm
a
a
minute. Hold on a
storyteller.
minute. Hold on a minute. Do you think it's a fact or an opinion that FDR is the first president to ever legitimize communism in
Do
1933 of November?
do I think it's a fact or an opinion?
Yeah.
are you gonna disagree with it or you accept it?
It's I don't think it's an historical fact,
Well, it
and
is.
I think it's open to.
And well, that's why your opinion is stupid. right?
Yeah, I know, but
You
hold on
think
a
a
second.
fact is open
But
for
hold on a
debate?
second. Calling an opinion stupid because you disagree with it that's that's not proper discourse. Like I might
Well,
think that your
actually,
opinion.
mine's not an opinion;
Dude,
it's a
you don't
fact.
even disagree though. You said that they were in a they were both in a fake war. It's like I don't even know where you guys
Hold on a
I
second.
don't even know where you
We're
guys
jumping.
disagreeing at.
No, hold on a second. We're jumping from the moon landing to flat Earth theory to fucking FDR to the
Dude, I don't
Soviet
even think
Union
anybody's
to
mentioned flat
Russia.
Earth.
We're jumping over like 3 or 4 or 5, 6 different topics. So it's
No one's
obviously
even
things.
mentioned flat Earth. We're still on the moon landing, and how you think Russia is somehow our mortal enemy, and you don't believe that.
No, I'm not saying Russia was our mortal enemy. Again,
You literally said it.
hold on a second. You guys keep saying Russia. So number
Oh my
one,
god! Oh
the
my god!
Soviet
The
Union doesn't
Soviet
exist.
Union. You know they're the same country, right?
Well, the Soviet Union doesn't
You are
exist
aware
anymore. It
that they're
hasn't
the same
existed in
country.
1990.
So you trying to get this distinction between the Soviet Union and Russia? It's they're the same country.
No, it's not because many
Y'all, it is.
countries. Hold on a second, Nick. If you can let
Went
me finish.
bankrupt.
Okay, 1 second. The majority of the countries that were part of the Soviet Union are no longer a part of the Soviet Union. The Soviet Union was a different kettle of fish. Russia is a country right now in 2025. You can go to Kazakhstan, you can go to Estonia, you can go to Latvia. The Soviet Union is not the same country as it was. The majority of these countries are European countries now. They're in the European Union. Latvia, Estonia, Lithuania.
Yeah,
They
thank
they don't
You
long.
think that
Nick,
bro.
you think that Russia, with its bases in those countries and its influence in those countries, doesn't actually control those countries? You're fooling
Hold-
yourself.
They don't have bases in them countries. They're European countries. I'm from Europe. I'm
In the
not.
stands, bro. I'm not talking about like Poland. I'm talking about the
wait,
stands, the Caucasus Mountains.
Nick. Can I just answer his question just to get it over and done with? Because he's doing Maiden.
Yeah, go
And
ahead.
you're not
man.
from Europe. You're from the UK.
Oh, wait, hold on. Oh,
Very
Wiley.
good.
Oh, Wiley, listen. I'm going to tell you exactly what happened, right? The reason that the Soviet Union fell and the reason that the Soviets went bankrupt was because of one thing in particular. At the end of 1945, there was something called the Yalta Accords, and it was between Franklin D. Roosevelt, Winston Churchill, and Joseph Stalin. And what Joseph Stalin wanted to do after the Second World War, he wanted to repatriate the Soviet nations back into the Soviet Union. The US and the UK didn't want that to happen, to create a different, I'm going to use sphere, but it's not a sphere, but a different sphere of influence in Europe. And what that created was NATO in 1949, and it indirectly created the European Union in 1957, which led indirectly to the Cold War. It was because of the Yalta Accords.
I'm not sure what you're talking about. You're talking nonsense because number one, the
The
Soviet
Yalta
Union ended
Accords,
in 1995.
yeah, the Yalta
Yeah.
Accords.
So what are you talking about? Why are you going back to 1940?
Are you gonna listen?
Bro, I don't know who muted that, but yeah. Dude, you
God
don't seem to be
bless.
grasping this.
That was me. That was me. I think this conversation about the Soviet Union and Russia and all that's about to come to an end. We got the Aether Cos guys in here. I think we can have a much better conversation,
Yeah,
in my opinion.
Well, he's trying. Yeah, this actually started on to the moon landing that it went there, and his basis is that because Russia didn't give it up, it must be true.
Yeah, that's what I was gonna say. Am I just wrong? Wasn't his initial conversation? Wasn't his initial question like if America and Russia were enemies and they were both faking space? Why wouldn't one give up the other? Wasn't that the original question, or am I just totally
no,
off
it
base
was.
here?
It was.
And the
It
other one
was.
he had was like, how could 400,000 people be in on it? So those were his first two original questions. Then he asked an additional question. You were correct to call him out for it. And yeah,
Okay, that's what I thought. That's what I thought. So that's all I wanted to know. If he doesn't want to go with his original question, then that's fine, and we can move on. But go ahead.
I never got an answer, but that's fine. We can move on. I never got an answer. It's two
Well,
questions.
no, and that's what I was gonna. Yeah, I was gonna answer that, and I tried to confirm that was it, and you're like, no, that wasn't my initial question.
Well,
So that's why I was just.
Okay, so I didn't mute the room and say that was enough of that. so that we could go right back into the conversation of what he asked, when he asked it, and every fucking thing else. Okay, so let's move on. We have Ether Cause in the house. I don't care. I really don't care what his original question was. He had a multitude of questions, a multitude of, oh, I meant this. And yeah, I don't care. So let's move on. Thank you.
Ooh.
Exactly. It's oh,
Dude.
you didn't answer my question, but even though it was his answer. But
No, I'm sorry, you guys.
What's up?
All right, sorry.
It's all good, lads. How about we talk about some triangles? You guys like triangles?
dude,
Well, I love
triangles,
triangles.
Dude,
man.
Dude, we've been making triangles
Hey,
in the
what's
sky lately.
what's that baseline there, Alan?
Ooh, well, I'll tell you what, it doesn't appear to be curving at all. Quite the opposite, in fact. Seems to be a flat baseline. So Stone earlier calculated some triangles in the sky using the shadows during the sunset, and they did not go in the globular based off of a sun setting on a globe. There would be a point where you would have a shadows that sweeps across the entire ground and just like knocks everything out. You would have a point in which shadows cast shadows that are higher than the objects that are casting it themselves. And Stone took some precise measurements, did a little little triangle game, and found that the sun sets, quote unquote, sets above the horizon. That's super weird. And there was a post about it earlier today by Ken, or what was it, last night from Ken, that went completely unaddressed. No one has said anything. And then my boy Brian made a little video using the celestial theodolite concept and eclipses, and showed that the sun and moon are always parallel to the ground. There's never any curvature to be found. And over the distances involved for his analysis, there would be, 2 to 4 million miles of curvature that aren't present.
Damn it, man.
Did you say 2 to how many million? What?
It would be 2 to 4 million meters of curvature.
Okay, you said
Oh,
meters. Did he say
said
miles?
He did say miles, but yeah.
Oh, sorry. Sorry. Yeah. No, it is meters. You're right.
Yeah, I'm kind of used to people misspeaking. He said miles. I knew he had to have meant meters.
That's many times around the.
But yeah, dude, and you'll see, like, if you go to Ken's post, you'll see the global responses to it are not to address the data at all. They're to boldly assert that first, like this one guy goes, that didn't match the flat earth prediction at all. And then later on, he doesn't even know what the predictions are. He's like asking in the comments, like, did you even watch the video? Like, the people that are engaging with us on the internet are just ghosts, boys. We all got to up our triangle game, and then just, it's about knowing it, for yourself rather than trying to prove it to other people. Because that dude's a literal robot. There's no difference between that dude and a bot that somebody made.
Well, yeah, most of the global engagement, like if you put like a paragraph, they for sure didn't read it before they start disagreeing. If you put a video, they absolutely did not watch it before they tell you why it's wrong. And if you do like any sort of comment or a thing, they absolutely do not read it or look at it before they go to tell you how wrong you are. That's just natural. Only for globers,
Totally.
it was.
Then
Dude,
there's the
that is the
Dobrin
case.
who posted an image of an apparent bibliography, which has obviously been artificially constructed, showing a bunch of papers citing some kind of psychological problem with flat earthers, and asserting, of course, that all flat earthers are either lying or fudging the data. And I responded to him saying, all right, in my video, in my presentation, just cite me one instance where I, quote, fudged the data. And then after that, in the same post, I quoted him. I just said, yeah, it is known, narf, and left it at that. The guy just triggered right out. He said, oh, you read 19 papers in 13 minutes? What are you talking about? And I said, okay, noted, none cited. because it's all about the straw man, right? It's not. He's never going to actually argue about the data. He's going to argue about how we're liars and we fudged the data, and that he's going to generalize his way out of this argument somehow. And he is sadly mistaken.
And then tomorrow they're going to be like, flat earthers never bring any data. Not once have I ever seen a flat earther with any sort of data that made any sort of claim or prediction.
And that's like the entire video is nothing but fucking data. Like, oh my God.
It's the art of
All
pretending
I
to have
wanna
an
know-
argument.
All I want to know is if Stone noticed that I use Rumble videos this time and not BitChute.
I did, and thank you for the hat tip. Just the same. Yes, that was very, very notable. You're all caught up with the links, man. Loving that.
Man, I don't know what the deal is. I didn't even see that.
Oh, I gotta find that. Who was it? Somebody with the celestial theodolite, right? I didn't watch the entire thing, but they basically rebutted with a Ruhif video indirectly. They didn't send it to me. They just said, "Oh, they'd be disappointed to see this," and it's some video with Ruhif giving angles from the center of the Earth, showing how the Habersign works, and saying this is how they got their distances. So they're getting their distances from a globe.
Yeah, that's our math premise. That is a spherical coordinate system. That is exactly how it works. We've been saying that for like I don't know, a year now.
It's our favorite thing to say, as a matter of fact.
Positions of the stars are calculated in a spherical coordinate system. So when they move in a hemisphere of vision and you calculate distances between that motion, yeah, that's exactly our premise. And wouldn't you know it, that radius value that we've been saying, and how there is an equivalent for, if you're going to use the latitude longitude system, when people ask us, well, how high are the stars and on a flat earth and all that? Well, if you're going to use the latitude longitude system, you could set them to the exact radius of Earth. And it's good enough. That's exactly what it's all based off of, and that's exactly what our boys showed with eclipses. When you calculate what the altitude would be off of that, it comes out to be the radius of Earth. So the exact spherical coordinate system that they're using, that's our premise. And then also, units of measurement are a ratio of that coordinate system, so it's internally consistent. So when you like that, that's what makes it so when they're like, how come I can go 50 miles here and it says that the distance here is 50 miles, and when I get out my odometer or when I get in my car it comes out to be 50 miles or 50 kilometers? Well, it's because it's a ratio of the coordinate system and it's internally consistent. So the distance between those two things that are calculated within that coordinate system using a unit of measurement derived from said coordinate system are going to be relative to that coordinate system. So if we had a different unit of measurement, right? Like the Chinese had the li, and they say that the li was off of they had to do a modern reinterpretation of it to link it to be half of to be half of a meter exactly, so that they can turn around and look at all the Chinese calculations from the history and go, oh, look, they were off of what, it really is, because we know that the meter, we know that it's a meter, but all they did, the li was internally consistent with their coordinate system because they were also using the angular relationship of displacement in the sky to movement on the ground. So they had the exact same thing, but they have to contextualize. But yeah, they have their own nautical mile essentially, and they have to contextually rephrase it to be like, oh, they were close, but no cigar. Oh yeah, dude, they were just exactly half off of everything that the quote unquote globe predicts. Guys, they had the exact same system for navigation. It's profound.
Didn't they have their own what was it for longitude that you were
shadow
talking
charts,
about?
shadow tables, right? They had a whole intricate shadow table system where they knew exactly, instead of Greenwich Mean Time, they had like Shanghai noon shadow time or whatever.
Yeah, Nolan's
Yeah,
based
that
on
was
sun
it.
travel. Yeah.
Yeah, so essentially, like whichever way you map it out, they did that. That's their own way.
Well, the sun shadows were for latitude. The longitude was determining the positions of celestial bodies
water
after
clock
after an eclipse, and then they would reference through their star chart when that star transited over, what's it called, Beijing, and then they would multiply that out by 15, and that would give them their longi.
Didn't you say they had water clocks? Because our story is we needed John Harrison, the magic carpenter,
They
to
had
build us the best
several
chronometer.
they had
But
several types of water clocks, and they also accounted for different barometric pressure at different elevations and stuff. They
so
knew
they could tell
they knew
time
all
at
kinds
night
of yeah,
beautifully.
dude.
Crazy. That's crazy.
They knew exactly what they were doing.
So are they like basically trying to say 100 miles on a globe is different from 100 miles on a flat Earth?
Well, no, it's tricky, right? Because they only
No,
define it with a nautical mile, which is
that's
related to how
exactly what
far you
they're
travel in an arc minute on the
that's
surface of
exactly
the coordinate system.
that's exactly what they're saying. They're trying to say like it would be a different thing, but they don't understand that it's an internally consistent reference because it's a ratio of the coordinate system itself. So it's not going to give you like you're not going to calculate the distances using that coordinate system that's going to be off. That doesn't make any sense. It's a ratio of it. So obviously it's going to be correct. So it doesn't matter if the Earth is flat or a globe. Using positions of the stars to calculate distances on the ground is going to be internally consistent. So it doesn't matter.
Yeah,
It's
and don't
not.
forget that that's the like the nautical miles, right? They treat those as if they're like one ratio everywhere on Earth, even though the relationship between nautical miles and angles in the sky is not linear everywhere on Earth. It's like they treat it as this like Euclidean box that's like scaled 1-to-1 everywhere. But we know that that's not the case. There's like a portion of angles in which it's linear, and towards the end it's not. So if the relationship for a nautical mile to sky angle is not linear across its entire range, how can the relationship between a statute mile and a nautical mile be 1-to-1 everywhere? It can't be. So there will be places where that distance ratio changes, but they have to have it be uniform everywhere if it's a ball, because a sphere is symmetrical.
I mean, isn't that what Einstein said too? If you want to think the Earth is moving or the stars are moving, it's just a coordinate system. You're going to get the same. You're going to get there.
I think there are recent geocentrists who quote him saying that, yeah, you can use if it's a coordinate system transfer, it doesn't matter. That's supposed to be the modern interpretation of with relativity and reference frames, and the speed of light is supposed to be, hey, every frame is equal because it doesn't matter, except secretly you always use the lab frame and you needed a frame of origin, and it doesn't matter all the time. That's why you invent coordinate systems like ECI to hide that and then transition everything over and then tell everyone that you're not doing that. Man, C plus V is like the coolest topic ever. I wish more people would just try to understand the motion argument, right? That dude who we were trying to argue with about, NASA and the government and the malintentions of the nefarious people who are maybe elected, like that's all hard to convince people who aren't just don't want to hear it. But if you go to like, hey, you know that thing that you need to have for your belief, the motion of the earth around the sun that you believe is, pivotal. It's happening 66,000 miles per hour, just equating to 30 kilometers a second. Well, turns out no one has ever in the history of the world measured that with any instrument known to man, even though we have the highest level interferometry, laser, fringe pattern analysis done over and over and over again at every condition to never ever show that. And it's kind of interesting. And what happened was they warped science around that fact to tell you that actually it doesn't matter and that you can't detect it, but actually you can only if you're not looking for it. And then
It's weird.
Well, yeah,
It's weird that they say that it's all relative and you can't feel it and all this other stuff and can't measure it and stuff. But somehow, some way, we got the speeds.
And then when you do measure it,
and the
actually
curvature
didn't measure it, but your instrument contracted in just the actually amount of way that you would have measured it if it was traveling at a speed. That's so you can apply a non-physical Lorentz contraction that would negate the C plus B and pretend that C is constant again. It's a wonderful system.
Yeah, but didn't they confirm curvature? Didn't they calculate curvature?
In
I don't
space
think
time?
I don't think
Yeah.
I don't think anybody's done that one, Huff.
So that they do like they reference curvature calculate when they do geodetic surveying over 100 miles. They adhere to their model, which is definitely an ellipsoid model. The whole point of geodetic surveying is to appeal and applied plane surveys to that ellipsoid model. So like, but like then they use that to say, look, we know the shape of the Earth because we adhered it to this model. And you're like, well, hold on a second. It's a little backwards. You're supposed to be proving that that is the shape. And they go, no, don't worry about it. We took care of that. We did a thing called the arc of the parallel. We did this measurement. We took a meridian and we measured the shit out of it. And you're like, oh, okay, that sounds legit. How much of it did you measure? Like, well, less than 1%, like about a kilometer or two. And then we put up these other spikes and we did a station, and then we eyeballed the stars and we took a calculation and we figured now that's about enough. And then we got it, and then we knew it was a sphere. And you were like, what? Hold on, it's supposed to be. How much of it did you measure with like chains on the ground? Well, like a kilometer or two. Okay. How much would you need to tell if it was a sphere or flat? Well, like 70 kilometers. Okay. So you measured it way under the threshold you need to detect and differentiate flat from sphere. And then you use those measurements conforming to the model calculated based on the astronomical latitude that you adhered to in the first place and called it done. Yeah. Well, that's exactly how you confirm curvature. So when they appeal to geodetic models and geodetic surveying, they're actually just taking all the measurements that they see in there. Whatever's not matching the model, they just adjust for, and everything is all predetermined. You can't actually do geodetic surveys without knowing the so-called shape of the Earth. So to say that that proves it is ridiculous.
Yo, did you see that paper that Guy McGuyerson just linked recently, where they were trying to do the old, oh, we just independently measured it, but they didn't. It was the classic trick where they were just still referencing the stars, and then at the end of it, they were like, yeah, we couldn't really determine our longitude that well, but we'll fix it when we're done.
Yep. I remember seeing that. It's like, nah, we got it. We totally did it. We couldn't tell, actually, it turns out, but don't worry. We'll just, on the bend, we'll know exactly where we are as soon as we get back.
We couldn't even tell, but like when we get back to the crib, we'll fix it.
We'll know exactly where we were. Yeah, I got it.
Sounds like when we figure out what we need, we'll know what to put down.
Yeah, let me get back there and figure it out what it's got to be first.
Oh, dude, what do you know? They just measured.
I don't know. That sounds like a post hoc.
It came out to be just enough in the discrepancy in the measurement for ball curve. There's just enough for angular excess.
Well, that's convenient.
For a ball of a radius of 3959.
Well, isn't that convenient?
It smells like dark matter and dark energy too.
So I don't know if Mr. Xavier's still here, but I was trying to give him the gist of your Prezi on Tuesday, and talking to him about that. So if he's here, you might could give him a little bit of that, because that was an excellent Prezi.
Dude, inshallah, Mr. Xavier's here, and thank you. That was an awesome. It was a lot of fun to learn all that and go through it.
Yeah, he was telling me about how you guys added some of the stuff that Mr. BS talked about with Void and his interpretations of what's going on with C+V. So I'm really anxious to see that. So I got that on queue.
Yeah, dude. It turns out that Lorentz control, like the whole framework, right, is basically just describing the oscillation rate change of waves with respect to a stationary medium. And the way that they have it set up is that mathematically, it describes the timing and spacing changes of the waves under transformation, and it keeps the speed of light the same when you do that, because it's with respect to the elastic medium. So it's how, like, we were kind of talking about it last Friday when that guy was like, well, how can an observer measure it plus or minus v, but it's a constant? Well, like Stone was saying, like how Eric Dollard likes to say, it's not it's a constant, it's not a limit. And what that implies is that it can be measured plus or minus the constant, in the same way that a sound wave can, which is relative to the medium. But yeah, when you go back through all the equations in what everything was derived under the principles in which they were derived, it's all deriving waves and how they're going to change based off of with respect to an elastic medium to kind of preserve their original waveform so that you could do the comparison. And then anyway, Einstein comes along and he's like, hey guys, what if there's no medium and I use the exact same equation and just say that it's relative to some other lad that's moving at a constant velocity, and that's why they make everything move at a constant velocity so that they can, transform it, to these arbitrary stationary reference frames, but they're actually, still requiring the same stationary reference point for a symmetrical transformation, which was the entire purpose of the frameworks that everyone was working with back then. And yeah, so if you have any questions or whatever, like, hit me up. And Piezo, I saw you were about to say something. What's up?
Oh, that's okay.
Didn't
It's, I
notice
mean,
that guy.
the medium, like, if you just think about it in terms of just motion, like if the medium's moving relative to the medium, the speed is c, but if the medium's moving, it's c plus whatever the speed of the medium is, or the speed of the object moving through the medium, right? Like if there's relative motion between the light wave and the medium it's traveling through.
Yep. And that's
So it's like a bullet that firing out of a moving gun.
yeah, and so they use the exact same equations to describe all of that. So one of the ways that you could interpret the timing and spacing of the frequency of a wave is the contraction and dilation of actual reality. So you can say that, that because of the way that the math looks when they math it out, like the way that the transformation looks, it appears as if time is dependent on the position, which is dependent on the velocity. So they interpret with no physical medium to attach that to. If you remove the conceptual medium from which it was derived under, then you would physically interpret that as, okay, time is dependent on position and velocity, and that's all they've done. And then Einstein goes through his paper. He doesn't derive the speed of light independently, like the way that he says he does for his postulates. He ends up using relative velocity to make the point, to establish a symmetrical midpoint, so he could have the two-way speed of light equal the one-way speed of light. And I'm sure you guys are all familiar with the ambiguity of the claims of mainstream, where they say that they can't measure the one-way speed, but it's all mathematically implied through the symmetrical framework. Because if the one-way speed isn't c, then the whole theory would collapse on itself as a physical mechanism. So
Isn't that called constancy?
That's where we're at with.
Isn't that called constancy? It's got to be the same in both directions.
Yes.
That's isotropy, actually.
Yes, isotropy.
To imagine being like, hey, I derive these, and then in your paper not deriving those things at all, and totally just taking it from the wave equation, but that came before, and then being like, guys, there is no medium, but here's my medium dependent equations, and like have no shame and have nobody like question it. And then
No shame, he says.
that's
shame.
probably why he wouldn't debate anyone, right? They were like, anyone will debate me, but we're gonna reject everyone and ruin your career if you ever attack us or say anything bad,
But I need a peer review paper, man. And I was like, what? Did he? What? No medium, but we're gonna act like there is one. Right.
Look at my equation. You see how I didn't change this term, but I did inflate these other two wildly, regardless of what they mean. Like, yeah, I just did that. Like, my equation got balanced, son. See that? Math and reality.
Math, man. I can math it out.
People ate it up, man.
Shout out to Franco.
It's so crazy.
Oh,
sorry, go ahead.
Oh no, it's okay. You can go ahead.
The Voigt transformation, which preceded the Lorentz transformation, they're the same thing. He was just borrowing it from our boy Voigt. He even acknowledges that. And then that later turns into the Einstein saying that he's doing his own transformation, but it's just the Lorentz transformation. It's the same thing, but he doesn't even credit Lorentz, which is kind of a red flag. But anyway, when you look through these guys' papers, when they derived everything, they're like, yeah, so it's well known that you can derive the speed of light in an elastic medium, and here's how the waves would change, and they give the math for it. So it's like they have these well-established ways to derive, the principles on which they're talking about with respect to a medium. And then Einstein comes along in 1905 with this same exact identical framework and goes, yeah, so the speed of light is independent of motion. And then later in his paper, when he goes to derive that, he's like, all right, so here we have a moving observer relative to a stationary system. And it's like, oh, dude, you didn't even do the thing you said you were going to do. you're gonna invoke motion for the symmetrical midpoint so that you could have the two-way be the one, equal to the one way. And yeah, it's just the failure to derive that independently means that anytime you hear, oh, we measured we confirmed time dilation down to the 16th decimal place, like when they talk about the muon, the G2 experiment and all that. Well, all that means is they measured something moving faster than the speed of light. Because if it's not the math that describes the changes for how much length contraction and time dilation there are, it's the exact amount of how much the velocity of light was exceeded or how much it was under. So the that's all that interpretation means. Like there's not even like you don't even have to come up with different math. It's literally all a ratio of velocity with respect to an elastic medium. That's
But
all
what
it's
about
that's all that's all
absolute frame?
that's all it's
No,
ever been.
really. Hey man, what about absolute frame? Oh no, son. It's all about the inertial frame. We don't talk about absolute frame in here.
And then define inertial as just anything that's moving at a constant velocity, so that they can do some tricky back end stuff to be like, well, it's moving at a constant velocity, so it's the same thing, it's equivalent as being stationary. If you were in a closed system moving at a constant velocity, it would be identical to being stationary from your perspective inside of it. So they use that like real fact, that real nugget of truth, to obfuscate and basically retard physics, because you can do an energy analysis, kinetic energy prediction, to see which frame actually makes the valid predictions for the relative motion that's going on in the frame, and you could determine that way. But like nobody, but apparently that technology and analysis is lost to mainstream physics, and it would be really painful to rebuild it or whatever. So they can only do an analysis through determining whether or not there was a change in velocity over time, and if there's no change, then it's inertial.
Yeah,
I
we were
guess the
just
whole
talking
point.
about that earlier. We were talking about a train example with talking about inertial motion, and just told them to be careful with that because they'll use that inertial motion a lot because when they know it applies to constant motion, and if getting your laws of physics from that lab frame works in something inertial, that's where they'll do the bait and switch. But to your point about time dilation, I mean, it's really basic when you strip it down to its bare bones. If two identical variables, right, two identical clocks, we're assumed the mechanics are the same between the two. They're identically synced. What is the difference? The only thing the difference between one of them is velocity. That makes it quote unquote age differently, right? So it's easy with the interpretation once you figure out where they're applying their BS.
And not
I
only
like
age differently, but age differently as a ratio of their velocity to the elastic medium, brother, on a
and,
one way. See, that's the
and how
other
much
thing too. Sorry, Nick, but real quick, that's the thing that they try to do too, is like, because there's no medium involved, they need it to be reciprocal. So when they talk about time dilation and they're like, oh, the twin paradox and all that stuff, all of that comes out of the necessity to the transformation being relative to some frame that has to be equivalent, and it's not. Like the dilation only happens in the moving frame. The stationary clock never desyncs proportional to the velocity of the one that moved away from it. That'd be insane.
and how much were those clocks off by?
Which ones?
Your favorite nanosecond.
The nanosecond, man.
To be fair, they can hella measure things and synchronize them on that frequency. Like it
Yeah,
sound
over a year.
Oh, I'm sure, but that's
if
totally time dilation, though.
if you pictured
Oh
the
yeah.
alleged 30 kilometers per second the Earth is allegedly doing around the sun, that if you dropped one clock off on our orbit and it managed to somehow magically stay in that spot as we go around for a year and then come back to that spot, those clocks would be different to the tune of about 139 either micro or milliseconds. I know that's a factor of 1,000 between the two, but you get the point about the ratio, that even at 30 kilometers per second, the actual amount of time dilation you're going to experience is diddly squat. This is what makes the entire thing so utterly unfalsifiable until we are able to produce a vehicle that can travel half the speed of light, or something like that. I mean, and you're talking about the difference between 30 kilometers per second and 300,000 kilometers per second. How close are we to hitting the mark here? Yeah, and it's a hockey stick, second derived curve to begin with. You know what I mean? That it does absolutely nothing until you're nearly doing light speed, and then all of a sudden time dilation jumps into play, and there's this shitload delay, and we're never going to see it. Never
All
going
uphill
to
to
see it.
possibility, man. I was watching
Exactly.
Brian Greene do a. I'm trying to learn this special relativity crap, man. I ain't gonna lie, man. It's imagination to the max, man. But he says we don't have the ability to do it now, but sometime in the future, maybe. So it's all uphill to possibility right there. They're not throwing it away because it could happen. It could happen. We could get a spaceship that goes to speed
It's
light.
the biggest mathematical mind experiment re-skinned as science that the mainstream has ever seen.
Yep. And then when they do measure something that's going that fast, or that exceeds their expectations or whatever, instead of looking at it like c plus or minus v to that small amount, they're like, oh, look, it dilated by that small amount. Because again, it's like the same equations, but they're just, their interpretation of them is insane, and they only kick in at velocities that almost none of, like, that don't matter at all to us. So it's pretty interesting how all that works. And believe it or not, there's even a smaller unit of measurement than the nanometer. It's called the angstrom, and that's what is it? It is 100 times smaller than a nanometer. It's crazy, crazy small. And that comes out of a ratio of the speed of light squared, 1/2 or whatever. So it gets really crazy, because they have these like really small, minuscule predictions, but then they have been measured, but they're just not, the interpretation of them, of it being like reality changed for that particle that's being measured or whatever, is like insane. What actually happened is that particle exceeded the speed of light, and it traveled a distance that was further than what was be expected if its half-life, if it ended, when it was predicted, when it was, if it was traveling at no speed or whatever. So,
For the record, though, an angstrom is actually a tenth of a nanometer, which makes
oh, thank
it
you.
1/10 billionth of a meter.
Oh,
If
thank
you
you,
picture
thank you,
that in your mind. Yeah, no
dude.
problem, dude.
Thank you, dude. Yeah, it's so crazy small. And yeah, like there was an experiment in 1938 by Ives Stilwell, who used the angstrom unit to make a measurement of transverse. Well, actually, it wasn't transverse in this case, but it was longitudinal time dilation, because it was this really, really small factor, but it was to that same exact ratio. So it was just, the speed of light was exceeded by a little bit. And that actually, in that case, it was retarded by a little bit. But um yeah, it's just really fascinating how they categorized and broke down wavelengths to that small of a unit. It's really fascinating. 1/10000000th of a nanometer is freaking insane, dude.
That is insane.
What's up, Mr. Xavier? Got your hand up, brother. You can speak.
Yeah. I was trying to get my notes together. I couldn't find it. It's all good. Yeah, but on top of that, also, what was I saying? Back to the original thing you were saying with the measurement, right? So, because that's their thing, right? They say, oh well, we measured it, like Alan put it. Is it something that happened while that that device was in motion, or the time itself warp and contract? So they'll say, okay, we both measured, so that's the standard, right? Measurement is the scientific standard, but you got to understand, is there interpretation left out of there? Well, we all have interpretation, but what interpretation of what? Is it something abstract, or is there local measurement there of something? Right. There was one thing that actually wanted to go over a couple weeks back. Something I have to get around to, like many other things. But there was a lot of disagreements on the video. But there was one thing in that video that I did like that was mentioned, that was spot on. Of what are we measuring? You got to ask yourself, what are we measuring? And And the example that I was giving in the video was, I believe it was mechanics between heat or something like that. But there was a mechanics of something, if there's a motion happening to increase molecular interaction, then the temperature rises. So we know there's a direct correlation there, right? So if we measure that, are we saying the work applied is proportional to heat increase, aka temperature rise? We can absolutely say that. So understanding when you're talking about that measurement, are you interpreting something that's locally measured, or are you interpreting something in supposition to that?
I
So,
think you're kind of hinting at Brownian motion, if I'm not mistaken.
yes.
Ah, very good, very good. And oh, I had another point there, but it escaped me. Be back.
Yeah,
Can you guys hear me?
Earlier escaped too, but
I can now.
Yeah, I
What's
can
up?
hear you, Pizzo.
Dude, my mic's been. I've been trying to talk this whole time. I've just been perpetually trying to fix Twitter. I'm sorry. Didn't mean to cut you off.
No, you good. You sound good. We saw you had an invite there, so.
Oh, the second point was that when you were talking about heating a substance, I think a lot of that is going to relate and fall back to the ideal gas law and the formula around pressure and temperature and how they interrelate. That's what you're going to find.
yeah, and relating to that, Taylor brought up something earlier, right? So, if a vertical temperature gradient is something that's significant when measuring refraction, and pressure is more as a significant value due to the density of what's happening in the air, that's something that should be acknowledged, right? So, if that's a better rating than quote unquote standard refraction, go for that. So even when they bring up measurement, you bring up more efficient measurements and ones that could do with little interpretation as possible.
Totally. Lapse rate is everything. And that's actually something I turned Taylor onto at the beginning of her path going down here, taking all the data on the salt flats and the rest that she did subsequently, that is the major, almost a dependent variable, but it's not. It's independent because you are witnessing the change of it in your data and how it affects refraction as a value on the whole. And it is really the predominant factor.
Yeah, I can't wait to see those notes. I don't know how long she's been working on it, but yeah, whatever she goes in hard or whatever she researches, so that'd be fun to see.
She was in here earlier today. She threw a post up there with some theodolite readings from the salt flats. She said she had some different ones to also talk about. She said she'd probably come back. So.
Yeah, but to put a button what I was saying earlier, but so when they talk about the measurements and it's full of interpretations that are, have a lot of equivalence there, bring up the dynamics like they talked about. If are we measuring for forces, right? If there's displacement going on, there necessarily needs to be a force, not a pseudo force. So, and they know this. There's a debate on whether they should change the definition of gravity and its properties. Is it a force, even though it's not directly applied? They know they're caught up with that because there's displacement happening. So they say, all right, maybe we can just get through it through a definitional an issue. So they're looking at rechanging it that to be a force and not a pseudo force because people are catching on to that. So
If it's not a force, they're giving up their dynamics.
yeah,
It's like, oh, we're just playing fictitious land, making all frames equivalent by math and just doing whatever we want. Sweet.
Yeah, but we'll socially shame you hard if you disagree, and good luck getting anything published that says we're wrong.
Welcome to the conversation, CAN. Welcome,
Hi,
good sir.
I'm
Hey, how we
John.
doing, man? Good to have you back. What's up?
Hey guys, nice to see you again. Wish you all a nice weekend. Yeah, it's written like a can of beer, but spoken out like Can. It's a Turkish version. Like in Italian, Gian. It's the same.
Cool. Almost like John in the Italian.
Almost,
Yes.
yeah,
Cool.
just with A.
So what's new? What's new?
What's what?
What's good? What's good in the hood?
Very cold here. Yeah. Everyone's ill. Yeah. Coldness. in Switzerland. I was here an hour ago. There was another issue. You know, a guy was asking, how it comes that Russia, the Soviets, and USA and the Alliance, how it comes that they didn't had a real war. So there are many reasons for that, but I mean, we are in another topic now, actually.
Yeah, Ken officially declared that a dead topic and fairly off topic a little bit for the room.
Well, I mean, it was about what it was basically his reasoning why we were able to go to the moon and play golf because
the Soviets would have totally let the cat out of the bag if we were lying.
Yeah, someone would have blown the gasket.
400,000 people. No, the only people that got to be in on anything are the people that
Well,
are claiming to be the space.
dude, I for one trust all the people who have every financial incentive to lie to me. So I don't know about you guys.
Yeah, I mean, we give them our money and they do it at gunpoint, and they have no restrictions on what they can do with it.
Yeah, I'm
The
comfortable with that.
the skill testing question that I ask people who posed that really newbie FE 101 point over and over, ask them straight up, do you believe that all governments practice the art of compartmentalization? Can you think of a government that does not? And work it from there.
That's actually kind of what I was looking for. Thank you for saying that.
I was going to ask, would the Russian mob oust the Irish mob, and why or why not?
He asked us, he's like, you didn't answer my question. And we did very, very thoroughly, pretty lengthy as well, but I don't know if we mentioned compartmentalization.
I was trying to think of that. I couldn't think of it, but I thought I went over it pretty clearly and precise. And he said it was just a story, and he didn't believe a damn word about it. All right, I mean, if you're just gonna pull the nuh-uh card at me, I mean, I can't.
Yeah. Well, when the people you're talking to, like, if you say a fact and they go, "I disagree," you're like, well, I didn't, I wasn't prepared for that as a response. To be honest, I didn't know that we could disagree with facts. I wasn't prepared for this.
Right?
Like, I'm not ready for this level of engagement. It seems. I think at that point, like, you just don't argue with those people about that topic. That's why I like the motion argument with C plus V, an actual, like, hey, where's my 30 kilometers a second? Where's that 66,000 miles an hour supposed to be going around the sun? How come it's not accounted for in anything like GPS or satellites or range measurement equation or anything relative to anything ever? How come it's completely absent everywhere, but it's super duper real and you guys know it's there? It's never been measured. I like that topic. That's like my favorite backbone, I think, of why geocentrism rocks.
I like Nick's famous quote, "Where's the motion?" Kind of like the old commercial where the woman's like, "Where's the beef?"
Wendy's, yeah.
Dude, I don't like that because it specifically gives them the sideways out where they just start and pretending like they were talking about sidereal motion, and they're like, "Look, Earth spin. See all the Earth spin measurements we have," and then that's kind of tricky because there are empirical measurements of motion.
Look at
right?
this
And we have
sine
to
wave that
interpret
corresponds
them.
to the stars and not the rotation of a ball. Oops.
Right, which specifically can't be because of the uniform rotation of a spinning uniform sphere, but could actually be the spinning motion of the ether above us as it pertains to the maximum minimums of the solar, maximum and minimum. So whatever.
And I
But
say,
yeah, like
I can see where you might be coming from, but might I retort and counter with Aries failure?
But like, I like to keep it to Earth's orbital motion because it's such a slam dunk, easy, no rebuttal. They have nothing. So like, when you allow them to go to sidereal rotation, it's much grayer, and they can actually argue. And there are two empirical positions, and you have to acknowledge that to be good.
What about a gyroscope?
Yeah, well, it's just it's easier to just orbital motion all the way because the truth is, there's nothing there. It's never ever been there, and it's super important. And they never have it, and I love pointing that out as often as I can.
I like when they bring up the gyroscope. First thing I do is ask them to not simply repeat the dogma, but to cite the data, which they are always totally unable to do because there isn't any corroborating heliocentric favorable data to any gyroscope performance. And even after that, I point him to the 35-minute analysis I did on Bob Nodell's data and how there was only one conclusion, and that is gyroscopes are not fit for purpose to measure this kind of motion. It's really that simple. And then finally, if you want to slam bang, you hit them up with every pilot's experience ever taking off with their gyroscope situated at runway orientation. They take off, they fly, they go somewhere for an unknown number of hours in an unimportant direction regards Earth's spin itself, which would actually add to the effect if they were going east. And when they land, what do you know? They hit the ground and the gyro tells them that they're still at the same angle as when they took off the last runway. And, it's they can't have both. They just can't.
Come on, Stone. They got pendulous veins that make that gyro rotate with the curve of the Earth
Stone,
now.
Stone, hear me out. Hear me out. Gravity probe B.
Oh, baby. What
Dude,
an
that how
absolute waste of
crazy.
70 fucking $70 million down the tube on that thing, man.
That's so crazy, bro. I've never looked into that until the other day when we found that stuff. And it was like, yeah, they built a mechanical gyroscope to measure curvature of space-time. And it's like, dude, for those of you who don't know, space-time curvature, like the equations that they use for space-time curvature are not going to give you something that a mechanical gyroscope is going to be able to measure with any sort of precision. And then so they spent, what was it, $750 million building this gyroscope. And
Yeah,
then
that's the figure. Thank you.
and then the data, it took them like 10 years of debating over the data, and they were like, yeah, it definitely confirmed it. It's
They
dude.
they spent amazing amounts of money and effort and time in constructing this gyro, this spinning piece of whatever the fuck covered in niobium film, but they didn't get it right. So there's a little bit of offset in their data they have to counter for, and then they're gonna float it and they're gonna hit it with EM to spin it, and just like on and on and on how totally exotic this device is. And then there's all the temperature controlling stuff, and they put it in a box, in a box, in a box, in a box that are all separated by super cold helium, because that might escape out into space, and that'd be okay if it did, because then it would be the same temperature anyways. And on and on and on, how they tried to get this thing to work right, but it just didn't work right after all that freaking money went out the door.
Unlucky, dude.
How is that gyro supposed to measure that light line is zero? The duration of a light line is zero. I don't see how that device is supposed to read that. But I don't know.
No, this was a mechanical one.
Yeah,
They
I'm
spun a perfect sphere quote.
Oh, they spun a perfect sphere. Okay, still doesn't get me how to get light line equals zero, but hey, it's cost millions of dollars and above my pay grade, I guess.
Not just millions, 750 million.
Imagine spending all that money and you're like, I don't know.
I wonder how many beach houses were bought with that money.
All they know is that they're going to have to build another one to get the truth.
Well, yeah, I mean, that's
Dude,
obvious.
that's
You
my
got-
favorite. It's like, look, we're looking for practical reproducibility. It's like all you need is a $750 million gyroscope to disprove relativity, dude. Well, you don't have one of those?
It's right in the paper. Oh, we didn't do so well this time, but next time we'll get them, boys. God.
Yeah, prices have increased though, so it'll be about 1.5 billion this time.
It'll be worth it, man. We're gonna find out some stuff. Maybe.
Well, listen, we're learning how to build vacuum-proof zippers from our astronauts in space right now, courtesy of NASA and your tax dollars. So I'm sure we'll find something to put on paper as to why we used all that money.
Didn't we do that in 1969?
I don't know. I made that up.
Really,
Is that
man?
something that they claim? Vacuum-proof zippers? That can't be real.
I mean,
Well-
it happened in '69. We should have it on the shelves by now. It's 2025, man. I watched the Jetsons and Back to the Future. That's all about this time. We should have some cool stuff, man. We don't have vacuum-proof zippers yet. That's some.
Well, they do have zippers on astronaut costumes that are supposedly vacuum-proof. I'm not believing that someone trusted their junk to that.
We are still also way overdue for the hoverboard. I'm pretty pissed. You know what I mean?
You were
We almost
promised a
got-
lot, Stone.
We almost got Rosie the robot, though, so we're getting there.
I mean, you can get a self-driving car, but it might kill you or it might drive you to one place where one guy calls 100 taxis. But
Man, these self-driving cars, man. I just watched a commercial and I was like, really? Talk about distracted driver. I mean, what are we doing here? What? You're just gonna let go of that wheel? Are you kidding me? I would never. I mean, come on. That's way too much faith in it. Really? Just trust in that. Okay. Okay. All right then.
They're too darn expensive too.
did you guys have Globers already that you scared off before we got here? Or was that the only one talking about NASA?
Well,
No, that was,
we had the decent one. What was it? Ghost something or something like that?
oh yeah. I
Yeah,
forgot
Ghost of
about him.
Peanut.
don't
Ghost
know.
of Peanut was in here. He said he'd be back too.
I don't know. Didn't he DM you their conspiracy? Throw him a DM.
Yeah, it could pop up in his DM. No homo.
Also, Ken, I know that you had a question about the swaths of Australia that are cordoned off last week. Luke sent me a message about the dingo fence that I had tossed in the pill and the jumbo.
Yeah, I thought we don't have any globies down there. That's pretty sad, man.
We were rich in trolls today, though.
Coffee's down there, bro.
Is coffee down there? Coffee don't
Yeah,
want.
we want coffee.
Coffee's a
does
flat
coffee
earther.
fall?
Oh God!
Where does
Do
coffee fall on the
not
troll
even
Glober spectrum?
speak
What do you guys
his
think?
name. The
He's
guy
a
has
full.
11.
He's a
the
full-blown
guy-
believer, man.
he has demonstrated repeatedly he is not capable of comprehending the discussion.
Multi-armor, man. It's multi-armor. Use a little bit of Newton over here, a little bit of Einstein over there, a little bit that curvature measurement doesn't matter over here. There ain't nothing he can't get by, man. He's impressive. Hold on a minute. Let me rotate some mics real quick.
I can drop down, but everyone retweet the space and appreciate everyone.
Appreciate it. Yeah, retweet the space. Got Ghost Peanut up here now. Got John Coffee up here now. What's up, Ghost Peanut?
Not much. Theseus said you needed a rounder up here.
Yeah, man. Heard you got some more questions.
Oh man. Yeah, what do you guys think about stars or yeah, let's just go there.
Anything in particular?
They're pretty lights in the sky.
Yeah, I mean, what do
Yeah,
you
do
mean?
you think like there's other solar systems out there, or do you reject the idea of a solar system because that would require there being round planets going around each other?
There's
Okay,
definitely
guys.
some
Sky,
other solar
man.
systems.
How much do you know about sonoluminescence?
That's the first time I've heard of it.
Then you're not prepared to have this discussion.
What do you want to teach me or tell me what it is, or?
Oh man, no, it's all about resonant cavities built in a strata of water being hit from all sides as a resonant function with sound energy. And as the energy hits the focal point and then leaves the focal point, light is generated. And mainstreamers won't even try to explain exactly where the light is coming from, how it is mechanically generated, but it is a well-known phenomenon. And I suggest you look up sonoluminescence. It's worth your time.
Okay, I'm gonna look it up now.
I think you can go on YouTube and type in "star in a jar"
Yeah, that's another good term.
and give a pretty good display there. What might be going on up there?
Okay, here's my other question. Do you guys ever get flat earthers who are deep down rounders, but who think the idea of a flat earth is so ridiculous, they get super invested and it's their super advocacy of flat earthing is just a deep troll?
Yeah, Peter.
Yeah, Pete the Jew fits that description right now.
Yeah. I was gonna say not really, but then you said Peter. I was like, oh well, there you go. Yeah.
Yeah, he's been hanging around my channel forking the same kind of bullshit. Oh, Stone is the man kind of posts. Absolutely substanceless trolling. Yes, it's happening as we speak.
But it's like so much deeper than I thought it was just listening to you guys that it would, yeah, I mean, you guys would probably immediately recognize if they're faking how much they're into it.
Well, it's not even that you have to immediately
Yeah,
recognize
it's not
it
that
when
hard
you've
to steal, man. Go ahead.
when it's not that hard to recognize when you've been speaking to that guy for months and months and months. I've even featured him in a video of mine called A Couple of More Thoughts About the Moon. Check my bio for my Rumble channel. You'll find that pretty quick. Yeah, that's not about guesswork. The guy identified himself long ago.
Okay, so this is my next question. Flat Earth doesn't necessarily mean 2D Earth. Obviously, there's stuff underneath us. And I'm sure different flat earthers think different things, but like what's the mainline flat earther theory as to what's underneath us, how deep it goes?
Okay, so how much do you accept a seismological theorem about the content of the core of the globy Earth?
Of the what Earth?
The content of the core of the globy Earth.
The globy Earth.
What is
Yes,
the core?
the one you were shown in school.
You know what
Oh, okay. What do I think about the content? Like that it's like molten iron spinning, creating
Yeah, all
magnetic
that
fields?
nonsense. What do you think of that?
I mean, that's what I believe to be true, you
And how
know.
did you
I
get to
mean,
that belief?
well, obviously, you know, I was taught that.
Exactly. Now, you see, I know it's something that you weren't taught was actual citation of material content through acquisition of anything farther than 9 miles down because humans have never been there. It's all done assumptively and presumptively through seismological manipulation of the data. And they say, oh, it's probably
and
this.
looking up
There's a
the
high
stars.
likelihood of that. Yeah, and looking at the stars. But you know, when we're talking about the content of the earth and what's in it, that's all you've been taught. And you're just, well, you know, that's how I got a good mark on the exam, so it must be true. This is the
Yeah,
psychosis we have to help people with. It's their indoctrination. Hey, and I'm not just singling you out, man. I'm a victim too. I've just overcome it.
yeah, that's why I'm asking for your theory. Because like I legitimately don't know what you guys believe in that
Well,
aspect.
that's
And
the thing.
also,
I got to stop you right there, Ghost, because it's not about what we believe. Okay, you see, this is the problem. And again, I got to stop you again at the very first thing you said about what does flat Earth say about this? Like there's Grandpa Smurf flat Earth that we all go and talk to get our talking points from. It's not like that. It's not like that in mainstream. I don't know why you would expect that to be the case in the flat Earth community. And frankly, back to the first point of these two, it's about the data. It's not about belief. This is how we build science. We don't do it through dogma. We do it through data. And globies don't have any bloody data besides seismological presumption about what the Earth is made of below the surface, because they've never been there.
So what does the data show? What is your interpretation of the data from our core samples that we have gotten and what we know so far?
My interpretation is that it's nonsense, Ghost, is that none of it tells us anything about what is below us in any substantive way.
Do you know what the
We're
radius
not
of
getting
the
the truth. It's not something we can know.
Do you know what the radius of the Earth is and how far the seismograph had to go down and figure out that it's a molten ball of fire with an iron core producing magnetism that surpasses the Curie point? 10,000
No.
degrees.
Couldn't do 9 miles, man. Couldn't do 9 miles out of thousands of miles of alleged depth.
3,959 miles to be precise.
Yeah, the deepest hole is 7.8 miles, and that's the Kola borehole in Russia.
And you know what they're doing? They're shutting it down because they can't
Okay,
get any
do you
deeper.
think? Okay. So this is speculation then, because it sounds like we don't have the data to make a full conclusion. But like, what is your, I guess, Stone? Is that who I was talking to? Did he just leave? Oh no, he's still there. Okay,
No, I'm still
Stone,
here.
what is your presumption as to how deep it goes? Are we like on a table, like an infinite table, or do you think it ends and there's something underneath?
You're asking me what my presumption is. It's like you're talking to another glober because every glober works on a presumption. I don't. We cannot know what is that far down because we have never been there.
Yeah, but I mean, you're allowed to have like, a guess. Like it's fun to guess. Like,
Well, guesses.
You know what I mean?
Like, why would the hell would I just talk about
A million
guess?
miles.
I'm
A million
not going
miles.
to convince anybody of my legitimacy by citing guesses. That's the mainstream's MO, not mine.
So what people tend to do, right, when they're like diving into this this worldview, right, is they want to try and replace everything that they currently believe, right? Like, well, if it's not the thing that I believe now, what is the answer, right? And there's like, and which is a natural response. Like you're gonna want to do that, but you have to realize you got to discipline yourself and understand that whether or not you're able to replace what you already believed before, that has no bearing on whether what you believe before is false or not. Like you can falsify it and not have anything to replace it with because falsification is independent of replacement.
You have to be.
Awesome.
Sorry, I thought you were done. Go ahead.
And so like for this particular question, like what's underneath us, he's right. Nobody actually knows. Like for me personally, I don't know, but my guess, like what I think, is that we have out and around us, like above us, to the sides of us, and below us in all directions, we have a bunch of water. At some point below us, at I don't know what point, but somewhere below us, in between all that water, there is like I think there's a narrow area that's like emptiness and just like a shaft or a tunnel or a void or something like that. But everywhere else, I personally think is water, because there's water in all directions. It's what flooded the earth, and it came from above and from below. But not
And
everyone believes that. But that's
yeah,
what I
and that's
think.
fine.
We can't test it. We can't test
And-
that because we can't get out of this terrarium that we're in. We can't escape it in order to go perform empirical science to measure these things.
Right. But
I'm
I'm
seeing
gonna
a
push
little
back a
irony
little bit
here,
on
Peanut.
Stone, and
Peanut,
it seems
Peanut.
like he's anti-guessing. And
Dude.
it's like you're allowed
Oh
to
no,
guess
I'm
and then
anti-guessing.
make
Did
a
you put a label on me?
hypothesis, and then we should be making hypotheses so we can go
You
do experiments and
anti-guesser.
prove those things
You know
wrong. You know what I
guessing's
mean?
no good, right?
Okay, Peanut.
Because
I got a
that's
fundamental
how science
problem here.
works. We make a guess, a hypothesis,
Peanut.
and then we go try to prove it wrong. And then if
Peanut.
we're wrong, that's fine. But we just
Peanut.
do it based off the data.
Peanut. I got a fundamental problem here, and I find it most ironic that the first thing you asked us about were trolls, and if we ever noticed them, or something like that. And is it easy to figure out who they are, or some other related question that you have in your mind along those lines? When your account right now, you don't follow anybody, and you have only 22 followers. That, to me, is the prime indicator that you are the troll.
I mean, I'm mostly on the silver spaces, and then Theseus goes on these, and so then I came on one of these. But
Mostly avoid my point.
Just real quick, the problem isn't that they're guessing. The problem is that they made predictions down the first 9 miles and were drastically wrong about things such as heat, pressure, time, the composition of materials, and then they pass it off as if they know all the rest of these things down the rest of the way. That's the real issue with me. That's all I wanted to chime in.
Yeah, and
it got
also,
rid of
I
deep water
just want
way faster.
Yeah,
They thought.
they said that we've only dug down 7.8 miles. They say the crust alone is 20 miles thick. I mean, we haven't even gone halfway through the crust, but somehow, some way, we know that we got a ball of fire, 10,000 degrees with an iron core in the middle that somehow is producing magnetism off of
Spinning somehow.
a
Well,
spinning ball of fire. Yeah.
To be clear, the reason that they didn't go deeper wasn't because they don't have enough ambition or anything like that. It's because like even the diamond tipped carbide drill bits that we're using to drill these holes are like melting at the temperatures and pressures at 8 miles deep, and they shouldn't be. Like that's like if you think about 8 miles compared to 4,000, that is a fraction. That's 0.2% of the depth from surface to core. 0.2%, 0.2% of the way there, and it's already getting that hot. Like it doesn't conform to their model.
It's worse than that. It's when they were digging the hole, when they were going every couple hundred feet, every 1,000 feet or whatever. They said, okay, well, we found this new material, we found this new strata, we found this new density, we found this new material. Okay, great. And now we're going to predict what we're going to find next, and they were wrong every freaking time.
Yeah, the magnetic field of Earth is not caused by some rolling ball of super molten metal that's not even magnetic at those temperatures.
Exactly. What about the Curie point? Good point. Good point.
Yeah, the Curie point that they're bringing up a lot is so like there's this thing, the response of materials to heat affects their magnetic domains, because what actually creates magnetism in physical materials is when the magnetic domains align in such a way, and the magnetic domains are based on the atoms in the crystal structure. So when the temperature of a material increases to a certain point, the crystal structure of that material will actually deform and change in such a way that the magnetic domains do not retain their magnetic alignment, and the magnetism of the material goes away. It's no longer magnetic. That's what the Curie point is. So basically, when you melt it, it's not lined up to be magnetic anymore. That's like the layman's explanation. And so they're saying that we're going to go super melt it, where it's like 2 or 3 times hotter than it needs to be to lose all its magnetism. And once we get super hot, it's just magically still magnetic somehow.
You get it back, man. You get it back. You get it.
Yeah, and then they try and say that because of the spin, that's what's creating the magnetic field, but that's still not even remotely okay or remotely scientific. Like, what other object, as far as I that creates a magnetic field by spinning?
Yeah, doesn't make sense, does it?
It's
And
more.
I was reading
more
that they
so.
estimate. Oh, sorry, go ahead.
Sorry, man. Sorry, Ghost. But more so that when ferric materials are dropping again below the Curie point, their magnetization is purely reflective of the ambient field around them at the moment at which that occurred. You know what I mean? The globies here are talking about this magnetized iron core. Well, how the fuck did it get magnetized? Where's the ambient field that caused it to become polar and dipolar in the first place? The whole basis of the mechanism there is not explained. And we can talk about a number of other subjects where globies do that if you like, but I'm sure you get my point.
Well, and then they also try and say that a ball is creating a magnet, which also, again, doesn't really make any sense. And I know I'm talking over Xavier and Sheepdog. I'm sorry. Go ahead, you guys.
You're a bit choppy there too, Huff.
Yeah, you're kind of coming in a little bit choppy there. What's up, Sheep?
One of my favorite ones personally, if Peanut's still there, is the way that we can send radio waves, especially millimeter waves, when things that are direct line of sight communications. We can send radio waves across thousands of miles just above sea level and receive them. And This was never thought to be possible. Basically, radio propagation has been amended and hotfixed and patch updated over and over and over throughout history. Every time they like make new groundbreaking, record-breaking like transmissions, they have to invent a new phenomenon to explain it. But like this one in particular, they had to invent like this thing called tropospheric ducting, where like these ducts open up in the atmosphere, and the radio wave just hops into this little invisible tunnel in the air,
Dude,
and
I
then
totally
rides through
believe that happened.
It rides through that tunnel all the way to its destination, then it hops back out, and then it gets received.
Of course it did. What else, man? What else? What else are you gonna say?
Yeah, but Battle of the Beams, bro. Like a year ago, we went through that really hard. Is like, dude, it's like such a dagger straight to the heart of the whole glob model, because it not only does this type of radio wave propagation, but it does it with triangulated signals that are both of the two triangulated signals that are shooting two different signals from two different points. Both of those are made of overlapping beams. So actually, you have four beams. You have four beams, two at each station, that are overlapping and shooting to triangulate to a point where a bomb target is, like 400 miles away. And planes just fly through a beam all the way there and then drop the bomb and then call it a day. That does not work on a spherical surface at all. They
So
did this
for
in World War II.
GPS, do you guys believe that? I mean, obviously, satellites aren't going around the globe to you guys. So what do you guys think about GPS? Because it's like the
Get him,
mainstream
Alan.
is like satellites.
I'll be back in a sec. Go get him, Alan. Just GPS the crap out of this guy.
They're going in circles above our head, dude, or ellipses or whatever.
Held up
shape
by
that they're
what
each
though?
taking.
Well,
Held up by what though?
See, on this GPS thing, I see a sheep there, but no one denies that there's something up there that they want to call satellites. All right, but most of your signals are going to come from the towers that are all around, such.
Yeah, but if they're
No.
not in orbit,
To try, what do they call it? Trilateration and stuff.
Oh, you're talking about how are they up there yet? That's a great question. There's several different mechanisms by which we, theorize that we know about, electrostatic tethering, some superfluid up there in which the typical tendency to fall down goes away. We don't know, and nobody knows for sure. The thing that's interesting, right, is like there's a lot of people that have satellites. This is well known. But even though a lot of people have satellites, very few people actually launch them, right? So like even people that do CubeSats and like, amateur stuff, these people don't launch them themselves. They give their satellites over to a rocket company, and then the rocket company actually puts it on board a rocket and then shoots it up there and dumps it out. And so it's like even the people who launch the satellites don't actually get to directly participate, I guess, in launching. And then all this stuff involved in the launching is completely tied up in ITAR regulations and information classification. Like even the pictures that they release to us are admittedly altered so that they can cover up the technology that's on board the satellites.
and so like when SpaceX live streams their rocket launch, it's all passed through the government first.
Dude, everything that you get is edited. A lot of the stuff that they give you is CGI, by the way, or overlaid with hybrid technology, like
your
partial
mic's
CGI.
crackling. Can you plug it in?
Okay.
Unplug it and plug it back in, I think.
What about now?
Yeah, it's still a little crackly.
Speak for a couple of sentences. Yeah, you're hella crackled, brother.
I don't know what to do.
Crackle
I think it's Twitter. It's not on Discord. I think it's just Twitter.
Yeah, it's a good thing.
Well, it's only happening to you, but gotcha.
It's a good thing we're not trying to call you on the moon, man. This would be sad. Be out there in a vacuum, all stranded.
Okay, do you guys think Voyager then is like completely fake, or do you think it's just like went off a horizontal plane?
Are you talking about Voyager? Are you talking Voyager 1 here or what?
It's just simulated data that we get back. There's nothing out there traveling, infinite
It would be
distances.
So
it
you know
would be
they launched
easy to
that.
fake.
They say they launched that in like 1972 or whatever. And it's
Yes.
been up there for like 53 years with zero maintenance, and it's still able to send us radio signals. And it's like 15 billion miles away, and the signals take about 23 and 3/4 hours to get here in line of sight communications. Yeah, man,
But
it's
even
totally
the
real, bro.
energy dissipation, like just the amount a radio wave dissipates over distances, and
Did
I
you
don't
not
know
hear
if you
what I
believe
said,
in
bro?
like the Maxwell equations or like
A
like
ghost peanut.
Inverse square law, etc. Yeah,
Yeah.
we do.
it
Did
would
you
be
hear
like
what I said though? How it's been up there for 53 years with zero maintenance.
yes.
Is it
Yeah, I
still
think it
able to
uses
send a signal?
radiation, so I mean, that's what they say. It has like two like mini like radioactive energy sources on it and a backup one and the main one, and the main one failed and the back, but that's what they say, right?
Yeah. 53 years with no maintenance, and it can still send signal to us with line of sight communications, and it takes about 23 and 3/4 hours to
Yep,
get
that's what they
with line
say.
of sight. And here's the thing, man, is that we're supposed to be orbiting the sun and chasing the sun and an expanding galaxy with all these other things moving around there, and we're getting line of sight communication.
The energy propagation does not make sense to me as someone who's like used Maxwell's equations and studied this stuff. It's like pretty hard to imagine a satellite or anything here would be able to receive that at all. Even like I can't believe it even comes close.
I know, it's almost like it's fake. What's up, sheep?
And the government did tell us one time that inflation was transitory. So
Yeah. Government, man. It'd be weird if government meant mind control, but don't think about that. What's up, sheep?
Yeah, man. Sorry if I'm roboting or if my mic sucks. I apologize if it does. Just let me know. I'll try to speak up. Other questions people ask: how do sunsets work? What does day and night work on flat Earth? I'll give you the short answer. When the sun is directly overhead, if you dive down into the ocean 200 meters, light will cease to exist from the sun. And so, if light can dissipate in water, it can dissipate in air. So that's what the effect we're seeing. The sun goes away, and then the light travels behind it, dissipating. Um, Seasons, the sun moves closer, further away. The sun's doing all the motion. What the moon is doing, I don't know, but it seems to do a monthly cycle. That's where we get the word month from the moon, Moonth. I mean, the sky looks like a complete clock, right? Like we base all of our time based off of the motion of the sky. And then at the end, after every question that you can think of has been answered in some form or fashion, even if there's not minimal uh, explanation to it, but it's sufficient, then you're going to be like, why would they lie, right? And the short answer is why not? Like you'll believe it. You're too lazy to go out and look for yourself. So why not lie to you and take all your money and resources from you, and just let you be lazy and sit on your butt all day. But at the end of the day, why they would lie is irrelevant. The fact that there is a lie even happening should be more than enough for you to get off your butt and go check for yourself.
I agree, man. I agree. What's up, Mr. X?
Yeah, I was pretty much tying him up to what was talked about earlier about the guesses. Someone talked about, well, it's okay to guess. Well, again, no one's really against guessing or speculation for that matter, but just have a method to your guessing. Is it an educated guess? Is it a prediction that we could test for actual testing, mechanical testing? And I put a couple of things up on the NAS just so you know what constitutes evidence, right? Because we're truthers here, but we don't seem to agree on what constitutes what's true. We had a presentation that was done by It's BS, and I shared a lot. And I'm not going to share it again, but the gist of it is, how is the testing happening with some of this scientific discoveries. I'm not going to go over it again, but the gist of it, you got to have a way to negate, right? Two people have two plausible interpretations that have equivalences. We want to account for forces. How do we go with that? Somebody has to be eliminated, right? Or both of them, right? Both of them could be wrong. So there has to be a method of chopping people off the wooden block. I mean, it's not a fun, you know, adventure to be a truther, but you have to have ways to eliminate possibilities. It's not fun. Sometimes we have personal attachments, but there has to be a way to do so. Why not? Because as Ken pointed out a lot with Popper's paper, it's very difficult to isolate a cause to an effect, but you could always falsify something, and that is key. And it's usually we talk about it in terms of cause and effect, but it's not always cause and effect, right? The Ether cause guys had done a excellent presentation going on what number, who knows what number now, about the celestial theodolite, and that also has a hypothesis, null hypothesis set up. So that's the main thing when we're talking about science: hypothesis, null hypothesis, right? And if this happens, then this must necessarily be the case, right? It's not always a cause and effect. Like it could be the CT observation, where it's an observation where something must happen if an observation is happening on. So if you don't have a way to eliminate possibilities, that's the biggest red flag in your methodology. You have to have a way to eliminate possibilities. If not, you got to revisit what you value, because it's not about value; it's about truth.
So, Ghost Peanut there, I see you run Boston. I asked you when you're in the space earlier that, if you were given some evidence to counter what you believed in, would you be able to change your mind? What was your answer on that again?
Oh yeah, I just gave like my go-to default on that is only a fool would not change their mind given new information. And I wouldn't say that like I've gotten like a ton of new evidence, but certainly I've been given a ton of new speculation. And like I wouldn't say like homework, but I've gotten a lot of good counterpoints that I need to go research on my own and double check some stuff and see, because it's really raised a lot more questions for sure.
Well, that's good, man. That's good. I mean, to try to expect someone to change their mind on the spot is a little high of an ask there, but and that's all I think anybody wants you to do is just check it out for yourself, because I think that's how everybody came to the conclusion. I don't know if anybody was convinced other than by.
So, Peanut, what was the name of your previous Twitter account before you started this one up?
Why do you ask?
Because it's obvious.
Okay.
So you're not going to answer? You're just going to admit
You
that
sound
you're a
like
troll?
somebody from Discord, actually. I can't put my finger on it. Are you on Discord too, Debate Flat Earth?
Am I on what Discord? Debate Discord?
Are you on Discord that debates Flat Earth?
Well, they
No.
said he was in some spaces with conspiracy theory on some silver stuff, and he brought him over here.
Yeah, that's
So
all.
you're
I just made this account to like follow silver stuff, and then Theseus, he showed up here, and I was like, I thought you all were talking about silver because it dropped like 6% today, and everyone was freaking out, and I'm like, oh, I'll jump in. This is where Theseus is. I think like another silver dude was in here, and yeah, but I don't have like an alternative agenda. I'm just, I mean, it's interesting. I've just been listening, and yeah.
Alan asked me to come explain my salt flat stuff. Did y'all
Tay
ever
Tay,
know?
is
What's
that
going
you in a
on?
dress at the Salt Flats?
Yeah,
What's
of
up?
course. Yeah, dude. So whenever you account for the vertical temperature gradient, as the Journal of Surveying Engineering says to do, whenever you're doing surveying along the ground, which is where we all reside, basically you're supposed to get the vertical temperature profile if you want to assume any sort of you know, refractive index. So whenever I did that, basically what it told me was whenever you just put in the temperature profile into the refractive calculations, that the expected drop over distance is more than what the globe would even predict. So it overcompensated for what you need, for, compensating for what you see visually. So, yeah, whenever you input the vertical temperature gradient, like for example, it says you'll see like a 9 or a 12-inch drop over distance. This is what it said in my, particular readings. But so yeah, that's more than what you even observe. So it's like more than enough to compensate for the visual effect and the ones that I've measured. I'd assume it would apply to others too. But either way, what I'm mainly promoting is more accurate measurements when people are using the theodolites. They need to get the vertical temperature gradient in order to calculate the refractive index so they can fully, make conclusive assumptions on their optical measurements to make, assumptions on the shape of the earth. So more data is all I'm asking. And yeah, so I did 3 trials looking at the vertical temperature gradient. Whenever I input the refractive index, it gave like the calculated refraction, it was closer to the FE prediction than the globe Earth prediction.
Unlucky for the globe.
Yeah,
No,
that's
you said they over predicted for what they like
Well,
for what they would predict optically.
well, what they say is that we'll see a drop over distance, which I think a lot of people that use surveying stuff can acknowledge, unless there's the circumstances where you don't see it, which is funny because they only say refraction is applied there. It's like really circular reasoning. So they say, whenever things are taller than they appear, when we see further than we guess, that's when refraction. But all other times, no refraction there. So that's kind of funny. But so anyway, so they say that things look taller, in standard refraction. They say things will appear higher over distance. But actually, whenever you're, putting the vertical temperature gradients along the ground, what me and others have found in peer-reviewed published research articles is that you get a concave curvature of light, meaning that things would appear to drop over distance rather than, be taller over distance. So what they did with the standard refraction, is they basically used temperature profiles from the upper atmosphere and tried to apply them near the ground. And that's not reasonable because, as I've cited in these peer-reviewed papers, they say that the temperature profile is not even close on the ground to what it is in the upper atmosphere. So that's how they can justify these optical findings. Whenever they do the theodolite measurements, they see it's somewhere in between flat and globe. So probably a little bit more closer to the globe, but it does appear taller. Like we don't see as much drop over distance as a globe would expect. So that's why they say 7/6R is what the standard refraction is. It appears a little bit taller, a little bit higher than the globe. And so that's what they say it is. But whenever you actually input the vertical temperature profile and stuff, what I'm finding is that no, you'd actually see a drop over distance. And I've cited those papers below.
Nice, Tate. Fantastic breakdown.
Kind of crushing, isn't it?
Turns out the salt flats are as flat as we all thought the name implied.
Man, imagine that. Refraction didn't save the day for the globe.
Speaking of refraction, Taylor, have you seen Vamby's presentation that he did on Aether Cause recently?
No, I haven't. He told me he was gonna do it, but I never got like a notification about it.
Oh,
Man, I'll
let me send you a link to it. But he's here now. We just pulled him up and put him on the
Yo,
spot
yo.
so he can practice doing the presentation again live. But yeah, Vamby, tell Taylor about your findings about the boundary interface required to create an image for it to even be so-called lifted up to begin with.
Right. Well, first I want to say what you just presented was pretty sweet. So you're saying that the upper atmosphere, they use the vertical temperature gradient from the upper atmospheres and put that and are using that as the data for the 1-to-1 curvature ratio the light needs to be having with the Earth for us to see too far? Is that what you were saying?
Yeah, they used the upper atmosphere vertical temperature profile and applied it to the lower atmosphere and assumed a standard gradient, but that's not what we actually measure.
Right.
It's
That's
much
really
warmer on the
interesting.
surface.
So you were measuring the vertical temperature gradient, and then you were looking through your theodolite. Is that what you were doing as well, and comparing them?
Yeah, so I'd basically get an accurate refractive coefficient to apply to my measurements, which in this Journal of Survey and Engineering says that you need to do to apply refraction. So people will look through the theodolite, then assume standard refraction, but multiple peer-reviewed papers warn about doing that. They say, and if you actually want to know what the refraction is, you need to measure the vertical temperature profile, especially, in the realm that the surveyors are, which is the lower atmosphere, that doesn't have a standard gradient as the upper atmosphere does.
That's such a good point, because what always happens is they just throw the word refraction around, and without having those measurements of the vertical temperature gradient, that's all you're doing is just throwing the word at it. And so you measured your temperature gradient to be, you said 12 inches per mile, like squared. That was the.
Yeah, I think it was like a drop of like 12 inches that would be predicted. And it's not
So that
perfect.
would
We
be
can
like.
only put it into the best calculations that we have.
Right.
I
Yeah.
haven't incorporated humidity yet, but humidity doesn't play that big of a role. But yeah, it's like over 8 inches per mile squared is what I see.
Right. So that would be a much smaller globe.
Yeah.
Yeah, that's really interesting. But yeah, about the boundary layer, I was just, I'm trying, I'm looking down the path of terrestrial refraction is a line of sight phenomena, and I believe as far as I can tell, the laboratory experiments show this, and so the image formation happens at the boundary layer. And so people use the example of when you ask them, can you show me refraction bending something around the curve? And what they'll show you is they will introduce a second medium, whether it's a prism or a gradient of water or something like, or some glass or a lens, so that they will need that to show the phenomenon. But the problem with that is a lot of people think that that's just kind of accentuating the phenomenon of refraction. But what I think is actually something very specific is happening, that is only happening when you introduce the second medium. Because what happens is the light travels, it's reflected off of the object we're looking at, and the light ray is coming through air. And then when you add that second medium, it's jumping refractive indices. And so when it jumps refractive indices, it creates a virtual image. And this is a known phenomenon. This is why you can look at a sink basin and you can't see the drain, but when you fill it up with water, the drain lifts up and reveals itself. So specifically what's happening is a virtual image is forming when you add the second medium. So to me, that's not an analogous example. That does not work as showing the phenomena of refraction bending light around a curve. It is unanalogous to terrestrial refraction.
Yo, Vambi, you're the guy that also said if you filled the whole room with water, you wouldn't see the drain again, right?
Right, yeah.
Yeah, that video, I've started it. I can't wait to keep going on it. It's fire.
Thank you. Appreciate that.
Yeah, I've seen this one video where this guy, he basically takes a propane tank, lays it on its side, and he's using liquid butane to create like a refractive index. And there's an object hidden behind the propane cylinder. So the propane cylinder is acting as the curvature of the Earth. Behind it is a bottle with a whole bunch of different layers of clay, different colored clay. And then when he drops that liquid butane on top of the propane tank, it creates like I guess a refractive layer, but it only raises like the lower portion of the clay. Like it'll raise the red up, but the blue above the red stays in place. You only see the red rise. And these people are trying to claim that that is, an example of refraction doing what they say it's doing.
Incredibly artificial conditions.
Yeah,
Oh, I
definitely.
agree. I agree.
So we have a butane we have a butane baller.
Well, it's like, how is the lower clay section rising, but the one above it is staying in place? Because it's just a manipulation. It's a Apparel trick. It's not doing what they're claiming is doing for their model.
That's exactly what Van B was talking about. You need that second medium to create, you need a drastic change to create that what's it called? The boundary interface, so that image can be, projected up or, moved essentially in a 1-to-1 state.
Yeah, it's the whole trick. I'm going to link you guys a video so you can see it too.
Yeah, because what they say, like they were talking about earlier with the with the lapse rate, the vertical temperature gradient, they need a homogeneous temperature gradient, so that they say that the way that the refraction would work is that it lifts it up, in a 1-to-1 way, because the gradient is homogeneous and it's like smooth like that. But like Vampy was showing, they don't have a single instance of showing that without invoking a drastic change or an entirely separate medium for there to be a boundary interface.
And then I don't know if you guys touched on this, but I pulled up some articles. I made a post on it. It's how they treat refraction and curvature as one. Like they treat it as one. They apply all the mathematics behind it, and then one cancels the other out. And I found a few articles on it going over it.
It's called the curve and switch. I think Shane's done a couple of prezzies on it.
The great switcheroo or whatever. Which really curving.
So at the end of the day, all that math and all that work is just proving our position.
It always does, man. It always does. But we do have a hand up. It's the mayor himself. JT, what's up there?
El Presidente.
Hey, thanks, Nick, for hosting, and the guys for co-hosting, and everybody in the panel. It's awesome to hear everybody talk, and it's a little mixture of X and Discord, mixing it up in here. But I basically came in tonight just to say much love and hi and whatever. But then there was the whole thing going on with Peanut, and I was formulating questions in my mind. Like I was going to basically ask him some stuff, which I still can. I see he's got a mic still, but then there was kind of questions about why is his account so new? Is he a troll? So really, I'm going to use my opportunity now. And Peanut, if you want to answer, you can. But I'm gonna take this opportunity just to speak to the people down below that aren't here to grab a mic, that maybe popped in the room wondering what the heck is going on here. I see flat Earth and like this is crazy, or
Dave's
asking
here,
the
yeah.
asking the question, are these people crazy? And so I just wanted to say, the question I had really is, how willing and available emotionally and almost spiritually are you as a being, as a person, to hold two ideas at one time? Like, be okay if it really is a globe, like you were taught when you were a little kid, be fine with that idea, but also question alternative cosmologies or alternative realms, if you will, or like, where do we actually live? What are the stars doing above us? Because if you can't even hold the globe as being possibly true and entertain, this other idea, then you're almost handcuffing yourself to a possible deception. Because if the globe is not real and you're down there saying, "Oh, it's got to be real, it's got to be a globe," and I'm team globe, and you're staking your flag right there on what we were told when we were little kids, then you might not have the opportunity to wake up like so many have in the room, because you hear people are well spoken, researched. I mean, the hours, the years that people have looked into what is or can you find and prove Earth's spin or orbit around the sun, or proof of curvature, all these things that people want to just like scattergun a million questions. Well, how is it flat? It can't be flat. you're never going to get to the truth. And I'm not claiming that I have it. I'm not saying it's flat and I know it's flat, because I don't think this realm can be known in its entirety. I do think water lays level. You know, if you ask me personally, I think that we live on like a dielectric plane, and there's like a double torus involved, where there's like an energetic field above us and below us. And like Piezo said earlier, there's quite possibly waters above and below and on sides, you know? So it's like we live in a sphere, not on one. And that's what I would stake my, like, that's what I would say I believe, but I could be wrong about that. But it's not weird to ask questions. It is a little bit strange to push against like mainstream consensus, because like a lot of people are trained and programmed just to believe, trust the science. But there's a lot of things that you can't or shouldn't trust, you know, with medical and with history, politics. There's a lot of people with skin in the game to control us as people. But if you just take a deep breath, realize your sovereignty, realize that if you're a man or woman, you have the right to investigate things and ask questions, you'll get deeper than just like being scared or scattergun. And so, yeah, keep seeking. That's all I had to say.
Yeah, and I think it's definitely something, my whole life I've heard like flat earthers, from various sources. I've never actually like listened to them. I've always been like, that's so ridiculous. It's not even worth my time to listen to growing up. And so, this is the first time I've like actually asked questions and like dug deeper at any level into this. And what's crazy is that it's honest. You guys are honest when you don't know something, you say you don't know. My whole history and like my whole like all through school, most of my life through college and like learning physics, there was never I don't know. There was always like a discrete definitive answer. So like and how open am I? That's a really good question. And I'm definitely not alone in this. There are people in here that will realize too that like it's going to take time to even question some of the things we've held as definitive for our whole lives up until possibly today for some of us. So, I'm just, it's a lot and it's like kind of jarring and shocking to even imagine living as me, as someone who questions the thing underneath my feet when I've never had that question. Because, you were punished so much, right? Like you wouldn't go to school, you wouldn't have a good future, wouldn't have a good career, like if you didn't get an A on the test or whatever. And that meant, knowing the definitive answers all the time. But, I not that I trust anybody specifically, but like I am definitely more trusting of people who admit they don't know what they don't know. Or, they don't ever claim to have all the answers. That's like more honest than 95% of anyone. So
Well, that's a great logical step to take. I applaud you.
Yeah, dude. And I was gonna say, like before, I was gonna say I appreciate your tone, your like demeanor and how you're like approaching the room, because most people do get triggered and irate and like just want to get angry, like we're the bad man for saying it's not a ball, or like we're taking the ball from you. But I think bottom line, the heavens have been talked about since the beginning of time, like since man originated, whatever story you believe about how man got here. This has been a thousands of year conversation. What is the sun? How does it do what it's doing? Where is it? What are the stars? And I honestly think that the globe model was birthed out of, it started with maybe good, like philosophy, let's talk about it. But then I think man became uncomfortable with the answer of like, I don't know. I think the conclusion is we can't go there and definitively measure the distance, or what is this substance? What is this light above us? Even though we were told, we got probes up there doing all this and that. I don't think that we, like our physical bodies or man-made ships, can travel up there to the luminaries. And so what happened was how we see the world, like curved visual space and how things appear to us. Um, Man has invented a dynamic and kinematic equivalence, like the motion of the heavens, how they appear to us. They made a globe Earth that has good math. It works. It does work. But whenever you realize like a plain Earth with the heavens moving over top, there's an equivalence there, and a lot of people just say nah. But if you really do the digging, you'll see that there is a dynamic and kinematic equivalence to the paths and motions of the heavenly bodies. I know that might go over, I'm not saying go over your head like you can't comprehend it. I'm saying when I first started on this journey, like so many times things were flying over my head. I would hear people and I'd be like, that guy has an ego, or that guy he has to be wrong. Listen to all that pride, but it wasn't that. It wasn't ego or pride. He was well studied, well versed, knew what he was talking about. Like people that get mad at Witsit or Allen or Stone and like personally attack him to death. That's really their problem because they haven't slowed down long enough to look through Stone's videos on BitChute. If you just go to bitchute.com and search Man of Stone and just
Cough.
slowly go
Rumble
through,
cough.
oh, I'm sorry. You got the Rumble going? Yeah, Rumble,
Yeah,
Man of
we put
Stone.
50. We put 50 of the more relevant videos up on
Yeah, I
Rumble
saw they were
last week.
popping up. Yeah.
Yeah,
So
it's all
anyway,
under FE Man of Stone.
yep, Rumble, FE Man of Stone, just take it slow, go through, because he puts the data, like the legitimate, real research data up there, and people will just say, no, Stone's a fool, all that's garbage, but it's not. And I just wish you well, brother. It's crazy to try to figure out the truth in all things. If you are seeking the truth, you'll find it. And yeah, that's all I want to do is just kind of pep rally the people that are curious, because it's worth asking, and it is worth seeking.
Well said, my man.
All
That was
right.
awesome. It's always
There you
awesome.
go. Well, I just love y'all. I mean, the friends in here that I have walked this journey out are like my brothers and sisters, and new people, I feel bad because they're like years behind on getting in on like what we've looked into, and it is scary. It is awkward. It's freaking crazy to even start this journey, but it's not impossible. If I can do it with 4 kids, other people can do it.
But it's always welcoming because this is our president. Imagine what everyone else is like, right? If we can just put that fake image into your mind and just sell you on that, it'd be everyone would join. It
Well,
started because the dude was like, "It's cool that you guys say you don't know what you don't know," and I love how you brought kinematic and dynamic equivalence into it because imagine telling the whole world confidently that you know the reason why everything in the world happens, why the stars move, the dynamic cause of mass attracting mass actually moves the galaxies and creates it's so incredible it creates black holes that go in upon itself, and you use Einstein to create mathematical demons in the sky to create a religion to scare people into not questioning relativity to control mainstream science. Like, imagine imagine telling the hubris and the balls on someone to be like, hey, guess what, I know everything about everything, there's literally nothing I don't know, that's how smart I am. It's almost, actually, as I say it, it sounds like Trump.
That's so funny, man. Everybody's done such good work. Taylor, thanks for your Salt Flats, stuff. Bambi, Alan, Shane, Nick, everybody, just everybody is doing such good work. Keep it up. People are definitely waking up left and right.
That's actually a picture of Cat up there in the trial 1 holding the survey stick. So shout out to her and Alan for coming and helping.
Nice. Yeah, that's awesome.
I just wanted to tag on the end of what you were saying, from Boston Bear, and a little bit of what you're saying, Ghost of Peanut, is we all know this. I can tell you understand this too. In school, you really don't learn shit, right? Like, what do they always say? You don't learn anything in school. You learn everything after you get out of school and you get into the real world. And like you were saying, everybody's in such a hurry to get an A on the paper. When the A in real life is saying, I don't know, when you really don't know. There's a difference between like what's physical and what can be physically proven versus what's just a concept and will only ever always be in your mind and never be out in the world. So kudos to you for at least recognizing that. And these guys, they say you might be a troll because you got you follow 0 and you got 22 followers. But I mean, you threw out Theseus, and you're a silver person, and I know Theseus loves silver. And so if you're a silver guy too, dude, like, yeah, your account makes sense. Who
And if
you
I
are on your
sound
other accounts.
Well, maybe my analysis is incorrect. That could happen.
I mean, it is a new account. I saw the no PFP. I kind of felt the same way when I brought him up here the first time, but I mean,
He sounds like
good
Theseus,
question.
dude. He sounds like Theseus a little bit. He
I mean,
kind of
he's
has
got
the same personality.
he had some good questions. He was being polite and honest about it. It's a tough thing to hear everybody say everything you believe is all stupid, fake, and gay in one day, and you probably got to go out there and think
Like, really gay.
Yeah, you
on
got
the same day that
on the same
Silver
day.
did the 6% slam down.
And then,
It's
yeah.
been a tough day for me.
So now you found out the world isn't what he thought it was either. It's like, is money even real? Is it just a concept that we just adhere to, and it really is just fake?
Well, that takes us back to last Friday night. But you know, I just saw somebody down in the audience there. Jenny G is here, and maybe you could throw her a mic because I'd really love to see or hear an update about how things are going with her new curriculum.
Well, I was actually saying to my co-host here that we actually have 3 in the queue there trying to get up as well. So we might have to rotate.
Oh, no doubt about it. Sure, sure.
Yeah, I'll
I'll
say
drop.
goodnight.
I'll drop down,
Yeah,
guys.
I'll drop as well, just because I'm gonna get some sleep. But y'all carry on. I'll listen for a little bit.
Shout out,
Yep.
Jeff.
I'm gonna
Right
just
on,
listen
bro.
too.
Much love.
Let's see now. Now there's Flat Lads is coming up. There was 2 other ones in there. Who was it? Jenny G is in the house.
Yeah.
Yep.
Maybe. Jennifer?
You there, Jenny G?
I'm here.
You got to put your pencil down. Stop taking notes.
All
Tell us all about it.
It's interesting, and it was really funny because when I came on, you guys were talking about, you know, some of the what was it? It was like the core and the crust and things like that. So I'm trying to teach earth science with a questioning perspective over everything, right? Like, and we've even talked about the fact that that, you know, they say that the core is, you know, molten nickel and iron, and yet that sort of counters the temperature and magnets don't work that way. So it's been interesting, to say the least. So I'm trying to at least teach my students, even if I don't have all the questions, I mean, all the answers to all the questions, how to ask the questions, how to sort of question the textbook.
Excellent.
Well, in terms of asking questions, I would always ask people, like, what experiments do they have to prove their evidence? And whenever you look into these quote unquote experiments, or they try to pull off observations now as like the scientific method. So whatever they're trying to demonstrate, say, can other variables account for that same effect? So, like, what other variables can affect these things? I found, like, with the gyroscopes, the gyro compasses, and stuff that they use to prove rotation, that magnetism can also affect these machines. So, like, there's other variables at play. So they need to make sure they're compensating for those other variables. Just like the theodolite stuff, like, what other variables can make things appear to drop over distance? Well, refraction. So how do you accurately account for refraction? You know, so that's something I found really helpful.
Yeah, I was going to, you know, my students are of middle school age, so you know, they are just starting to grasp some of the you know, basic concepts. But I really was wanting to, my next thing is to have them kind of understand that a lot of the technologies that we use for investigation are large site technologies. And so the resources that are like very layman sort of oriented would be very useful.
So what kind of student reactions are you getting, giving them all this new thinking to do?
Well, I don't have anybody, they're young, you know, so they accept it as just the way it is. I I teach at a small private school, so I have a lot of flexibility, and they they understand. I mean, they understand that I'm a questioner, and so what they're going to do with that as they go forward, that's what I hope that they say, oh, it's okay to question the tech. It's okay to think outside of the box. I have, when I've had, this year I have a lot of younger students. I have a lot of older students that were a little bit more ready for some bigger concepts, but it's been fine, and I haven't had any pushback from the students, and I haven't had any pushback from the parents.
Cool. I was about to ask you though, has any of the faculty or administration audited your class?
Well, not exactly audited, but the administration kind of lets me do whatever I want to. And I'm always using the textbook as a backbone, but then jumping off of that. And then I'm teaching them to question the textbook as we go forward. And I do that I've done that in my, in my biology classes. I do that. I actually teach high school biology right now. But and so we talk about things that are controversial, and I have not yet had any pushback. So I'm just going to keep going forward.
Well, that's fabulous.
I teach biology too. Well, this semester I'm actually teaching scientific communication, but I've taught many biology courses in college, many college biology courses. Something interesting that you can mention to them is like, just in terms of proof of creation, like going against this atheistic agenda, is that, life cannot form on its own. Even with all of our best technology, we cannot create life in a lab from non-living material. So it's really amazing. They don't have like a working, reproducible theory for how life even began. So that's a whole topic I did done like a 2-hour presentation on. And I spent like numerous hours, compiling the latest research in abiogenesis, which is origin of life. And we see these things don't happen on their own. And like there is indication of intelligent design within our own cells, such as the complex, informational hierarchy in the DNA, the complex specific information in DNA codes. We only see that with intelligent designers.
Yeah, like with Michael Behe and that's
Yeah. Yeah, I love them. They're awesome.
Yeah, I'm familiar with that. And the schools that I work at are traditional Catholic schools. Well, Catholic schools. So talking about the creator as the origin of life is very natural. So I'm a kind of swimming, with the current, but kind of pushing it forward at the same time. So yeah, that's I think why I don't have so much pushback, is because I'm not in the secular world.
Good. That's awesome. Promote them to ask questions in general. What experiments have been done to prove this, or is this just like an ideology founded in philosophy? How did they come to this conclusion at first? Are they like reifying the consequence, like affirming the consequent, where they're not really like doing experiments, but they'll take an observation and say, oh yeah, that's what we would predict if XYZ, that they already have a preconceived notion of. You know what I mean? So
Yeah, that's
once you look into, you'll find it.
with my sorry, I don't mean to jump in.
That's okay. You'll just find that's the case a lot.
In my biology class, the next thing we're going to talk about is bacteria. And their textbook has a lot of verses, and I have a very, very view of virology as a science So that's going to be
Wow.
interesting.
Jenny, you're coming in pretty robot-y there. Are you able to get closer to your ISP somehow and improve your connection?
Oh, probably not. So maybe I should step down because my
Just thought I'd check.
my
No, most of it's
internet's a little
clear. Yeah, but internet spirit is sporadic like that. Yeah.
Well, it's been great talking to you guys. I'm going to drop down. But like I said, and anytime anyone wants to DM me anything that looks like a really good lesson plan, please do.
Cool. Thanks for the update. I appreciate that.
Take care, guys. I love it. I love the conversation.
Well, thank you very much, and thanks for stopping by. Well, we got a couple hands up here. What's up, Jonathan? You still believing in the globe?
Yep. How are you doing?
Doing well. Doing well. Have you looked into anything?
Not lately.
Mm.
There's still some stuff I'd like to look at. I know that Shane sent me a link to the spreadsheet on the celestial theodolite thing. Was not able to get anywhere with it. So hopefully, Shane, if you're listening, I can get with you and hopefully get access to a spreadsheet so that I can read it and it's not granular and hard to read. But yeah, just hanging out. But I was just listening to the conversations and thinking about, how it said that, the heavens above don't describe the shape of the earth below. And then I know that Boston Bear was talking about the kinematic equivalence thing, which, either we're spinning around or the universe is spinning around us. But I think the thing that doesn't really the thing that doesn't really dispel is the internal dynamics of what we see out there is still a perfect match with a solar system model.
Is it really?
So then either the solar system is spinning around us or we're spinning around inside the solar system. It doesn't succeed to destroy the success of the solar system model.
What do you mean on that?
Do what?
What exactly you mean on that?
Well, if even if I grant that the things around above us in the heavens are spinning around us, even if I say yes, that's true, it still does not take away from the overwhelming success of the solar system model to explain the internal dynamics of the bodies.
Hold on. You say that, because that whole solar system is the thing that's spinning above us, right?
There are no solar system dynamics, dude. Solar system dynamics are governed by a ratio of constants and periodicity. And GMM over R squared, the mass cancels out, and it's just a ratio of the periodicity and the two constants involved, which gets reduced back to Kepler's laws, which are just a ratio of the periodicity over pi to give a distance and velocity for everything. So there are
I don't think mass drops out though.
Yeah, it absolutely does. And it just becomes a ratio of the two constants involved, which would be the mass of the sun and big G, which would be the gravitational potential. All the other masses cancel out, which just make it kinematics. So because it's just strictly kinematics, that's the great trick. There is no dynamics of the solar system at all. It's always kinematics. No one's ever had any dynamics. And then when they started finding things that extend out, quote unquote, beyond the solar system, they had to introduce an additional mechanism to substantiate their previous claim of dynamics, which was, mass attracting mass. So that's where they came up with dark energy and dark matter to introduce enough gravitational potential in an area where the amount of gravitation that they would predict based off of the luminosity of a galaxy per se doesn't match what it's needed to hold it together based off of its rotation. So they're just like, oh, it must be this, it's basically just an algebra equation where they're like, how much do we need? Well, we supposedly have this much and it would take this much to make it work. So that must be how much there is. And it's like, that's not dynamics. That's dog shit.
I would like to go over that math at some point. Obviously, we can't do that right here, but even if, okay, so I could also grant that mass is not really relevant here, and it's all just motion, where something is at a given time. And so, but even there, that's my point is still that if you take the model of the solar system and just say, okay, I'm just going to say that 2 days from now, all of these bodies are going to be in these locations. I don't even have to tell you why I think that. But if I say that and then I simply use the laws of perspective and I look up in the sky to see if it's so, it just is. And so my point is that you can say that everything out there is spinning around us and we're stationary, but the thing that we're looking at when we look out there is a solar system, and that's my point.
Sure. So these two things that you say that are going to happen at this time, if it
that's
happens
called.
at that
That's,
time, if it happens
sorry.
at that time once a month, every month for like 12 straight months, is it more of a pattern or a prediction?
So, dude, exactly. That's just a ratio of a periodicity. That's exactly what we were talking about. Like, that has nothing to do with dynamies. So with no dynamies, there's no mutual exclusivity. Like you said, you wouldn't even have to tell somebody why you think it moves in the way that it does. But the fact that you quote unquote predicted where it's going to be, but you predicted where it's going to be after, like, via empirical observation, via it completing its cycle in the first place to get the periodicity to make the prediction. So you're never predicting anything. It's always a post-diction as a ratio.
I mean, yeah, you can tell that Jupiter is going to be around this constellation 12 years from now. I agree. And you don't need to know anything about, you don't even need a solar system model to do that. But the thing that makes it special is I can tell you exactly where it will be in that constellation 12 years from now, and then it'll be in a different
literally
location
called
24
kinematics,
years from
bro.
now.
That's just
Do what?
kinematics. That's just relative motion, bro. That has nothing to
Pattern
do with
recognition.
dynamic cause. Your initial premise was starting with the dynamic cause is the beauty of why it works, and now you're just describing kinematics, and like that's not, nobody cares. Like, so if there was actual dynamic motion of the Earth, Michelson-Morley would have measured 30 kilometers a second. They wouldn't have had to have co-opt all the ether equations, which are velocity ratios relative to an elastic medium, and how the frequency of a wave would change with respect to that velocity. And they wouldn't have had to co-opt that and then turn it into link contraction and time dilation of physical reality to impose a velocity that's never been measured, to then turn around and say the reason we can't measure the velocity that we know exists because we're using ratios of movement of objects in the sky to substantiate it. We know that that's true, so we know that our apparatus must have shrank by the exact velocity that we're traveling. Like, that's so retarded. And then the fallback on it was, well, I know where this star is going to be in this constellation 12 years from now. That's just more that's actual kinematics, dude.
Well, at least I'm a friendly retard.
Well, you can see that point, can't you? You can see how that's just basically pattern recognition, right?
Well, to a point, yeah. I mean, you can tell that Jupiter is going to be in that part of the sky 12 years from now.
To what
You're
part,
missing it, buddy.
To what part is pi and the periodicity not ratioed against one another to get that prediction of when it's going to be there, dog? Like, what you're just restating our premise as your conclusion. Like, anyway, Stone, I'll be back. I'm gonna go do something. Be right back.
Okay, cool. Well, I'd like to take you to task there, Jonathan, just for a sec, if you don't mind.
Yeah, I don't mind.
Okay, so let's get our eyes out of the sky. Let's just deal with terrestrial effect in terms of causality. Now, you're saying, and you mentioned the word spinning, so I'm going to work on that only. Okay. You say we're spinning around the solar system. Well, we're supposed to also be spinning around once every 24 hours, right? And we're supposed to have a radius of the Earth of 3,959 miles, give or take, right? Okay, good. So when you start to blow out the centripetal force and the Coriolis force and all those cool things, and you start to really consider how we might see that in what we observe terrestrially, let's just deal with the spin. Now, if that were true, and as in spinning around once around every 24 hours, but also doing 30 kilometers a second around the sun in a curvilinear path. I love that oxymoron. What we're looking at here is a literal change, and it's a quantifiable change in lateral acceleration, not just the x vector moving in orbit as we go around the sun, but the y, because of the local spin on that axis, which we perceive through the poles, quote, that axis, through the Earth, the globy Earth. Okay, great. Well, when you quantify that, you get the GMM over R squared thing together, you get the 1/2 MB squared of thing, you put it all together. What you finally arrive at is, I think it is 2.1 centimeters per second in lateral acceleration. Now, that's not zero. That's a significant amount when you talk about how precision laden all of the papers we see written up on this in the past 20 years boast in terms of their instrumentation and what they can measure and how small a force or small an acceleration that they can measure. But they never seem to be able to do that. But ignore that. Let's just take the figure 2.1 centimeters per second in terms of a lateral change. And that's only an average value, mind you. It goes to 0 and it gets up and it goes past that, closer to 3 centimeters per second in terms of a lateral acceleration, in terms of our net velocity change going around the sun. Can you picture that?
Yep.
Okay, great. Well, I'm sure you've been to the lake. Doesn't matter where, all the lakes are the same. It's just a body of water sitting flat in an indentation in the earth, right? That's where all the water is collected. And there's two things we don't see. One, we do not see cyclic motion of the water itself in terms of its position in the lake. That it doesn't swish to one side and 6 hours later comes back to the middle and swish to the other side. 6 hours later comes back to the middle, cycling every 24 hours in that. We never see that. It just doesn't happen. That is something that we would see if that 2.1 centimeters per second wasn't fiction. If it was actually real, if we were actually spinning, if we were actually going around the sun, that would actually be a measurable acceleration, constantly oscillating with a 24-hour periodicity relative to our vector going around the sun, being the x, right? What we don't ever see is that reflected in a body of water, a lake. Now, forget the oceans. That's too big to look at. I'm just talking about a lake. That could be a mile across. It could be 20 miles across. It's a flat piece of water sitting on land that shows no oscillation in its height side to side. 6 hour oscillation. It's just not there. The other thing that we do not see is the Coriolis effect. What about this Coriolis thing that the Globies love to talk about when we're shooting bullets and we're flying planes? Screw that. What about the lake? Based on the lake's latitude, there would be a southern directed influence in the northern hemisphere on that body of water, wouldn't there? Because it's spinning around the axis around the pole. Why don't lakes naturally tend to drain to the south in the northern hemisphere, mostly, in the 40s in terms of latitude? We don't see that. You've got to come to grips with this, Jonathan. What's up?
Wouldn't we see that in a pool too, not just a lake?
Well, pools are very small. What I'm talking about, to give you a grip on the ratio here of depth of the water versus span of the lake, it's the same thing that would happen in your kitchen when you grab a baking pan that has upturned edges around all 4 sides. So the thing is maybe 1/2 inch high, 3/4 of an inch high, but it's 18 inches wide and 24 inches long. You know what I mean? And it's sitting there on your countertop. Fill that thing halfway full of water and try and move it. Try and pick it up and take it to somewhere else in the room and see what happens to the water inside it. With just the slightest bit of acceleration or this direction or that direction, you're wet. That water's on the floor. But we never see that on a lake. Never. That's the problem, Jonathan. This is where you get to ruminate and guess and conjecture about what I just said.
I was going to say gravity incoming.
Oh, I was muted. Sorry, I was starting to give that answer.
Yeah. All right.
So the way that you can conceptually process that is, so yeah, there should be a southern influence. I agree. If the Earth was perfectly spherical, you would have that. Now,
Wait,
no.
define perfect.
Yeah,
How
I mean,
off
what,
is it
what
from
does
perfect?
perfectly spherical mean?
Bear with me. So, perfect would be like, 3,000.
For the globe model, forget what it would be. For the globe model, how much off? What's the percentage off from being a perfect sphere?
I mean, even if it was even if everywhere on Earth the diameter measured 3,959 plus or minus a mile, even if it was that close to perfect, you would have southern flow in the northern hemisphere and northern flow in the southern hemisphere. But because it is oblate, you essentially have an upward climb as you go from the North Pole to the equator, and then same on the other side. You would have you'd be climbing essentially with respect to a perfect spherical datum. You'd be increasing in altitude from that datum as you went from the southern pole to the equator as well. So,
okay, so to quantify what you're asserting, you're saying plus or minus a mile over a radius of 3,959 miles. You're talking about 2/100ths of 1% of variation in the radius. 2/100ths of 1%, and you think that amounts to a hill of beans. Regarding what I'm talking about.
I plugged it into AI before, and it gave me an analogy. If you shrunk Earth down to the size of a basketball, the bulge at the equator would be less than the thickness of a single business card.
Hey, Jonathan. Do you know why they say? Do you know why they say that it's an oblate spheroid?
Yeah, because it's oblate means flat, or it's derived from the word means flat.
Non-spherical, fatter on one half below, less fatter on the half above. It is out of spherical means. That's what oblate means.
Okay, so do you know why they call it oblate?
Yeah, because
what is the mechanism behind why it's oblate instead of exactly a sphere?
Centrifugal force.
Of what?
Of a rotating sphere. It bulges because of centrifugal force, yeah.
Okay, so what Stone here is asserting is exactly what would happen to the water because it is happening to the land. Is that incorrect, Stone?
I think you have it.
So, in other words, what Stone is saying is exactly what would happen because it's happening theoretically to the land. So it would also have to happen to the water.
Correct. Regardless of the shape of the land.
And this is easily verifiable, by the way. I mean, the basic approach to doing physics problems is you have to break down the forces. So you have a force of gravity going, well, let's not say gravity. We have a force that we call a force in association with objects falling at a certain
we can call it gravity. I
acceleration.
got no problem with the term gravity until you start to talk about cause. As soon as you start to assert that mass attracts mass, I'm going to cut you down. And I'm going to quantifiably do it. So be ready for that.
Okay, we can go there another time. I'd be happy to. But
no, it only takes a minute.
To stay on topic here, let's talk about forces. So there's the downward force, and then there would be a vector added to that that is due to centripetal force of a rotating object. And so if you add those two vectors, and by the way, the one that is produced by centripetal force is much, much smaller than the one for gravity. So you have just a very slight angle change once you add those two vectors together. And that angle change, I would bet money on this, that angle change would coincide with the amount of tilt of your area of the globe with respect to a perfect spherical datum.
Okay, absolutely none of that addresses the 2 points I just made.
Oh, I'm sorry. Can you tell me what the points were again?
You see, all you were talking about was the algebraic sleight of hand used in the computation of what we establish as vertical.
It's not sleight of hand. It's logically consistent.
Sure, buddy. Anyways, the point being here that you are talking about how to define vertical in terms of forces and exchange between centripetal and centrifugal. I am not. I am talking about tangential, acceleration, lateral to vertical, 90 degrees from vertical. The variables that you cite are not relevant in the analysis I just gave you. And if you would like to further the conversation regarding Earth's centripetal versus centrifugal forces, etc., I invite you to immediately cease and desist just for a couple of minutes here, because my videos are very short. Go check me out on Rumble and go see 2 videos. They're easy to find because of their titles on my channel on Rumble, FE Man of Stone. Go and see a couple of thoughts about the moon and a couple more thoughts about the moon. When you want to talk about adding vectors together, that is where we will start in the conversation, and you need to see those 2 videos so that we will have common ground to speak of. Is that fair?
That's fair. I'm writing it down right now. A couple of thoughts.
They're only like 5-6 minutes apiece. You can do them right now. FE Man of Stone on Rumble, and you can just frankly just click my bio to get there. And go see a couple thoughts about the moon and a couple more thoughts about the moon. And I invite you, and I cannot stress this strongly enough, to use the pause key frequently, because I do not mess around with time management. I do not fart around with the subject. I lay it down, run it by, I show you the figures, and we're done. So you may miss the point. You may totally miss the point if you are not using sufficient pause key action. Got me?
Yeah, I used the pause key, and I did on the last video I watched of yours, which I would like to talk about at some point. Yeah, I wrote those down in my notes, and I will talk to you after I watch them.
Looking forward to it.
Does anyone else in the room want to talk about vectors? Because the point that I was making was, do we all know how to add vectors? I don't assume we all know, but there's the X, Y, and Z component of any vector, right? And so you have 2 vectors, and they all have their components.
No,
you
not
add the
every
X's
vector
together.
has an X, Y, and Z component. I'm sorry, no. A vector is made out of 2 scalars. One can be temperature, one can be modulus of rigidity. You know what I mean? Vectors can represent anything in reality, not just motion or acceleration or a force. You know what I mean?
Oh, yeah.
That's not what vectors are for.
But when we're talking about spatial things like physical forces, things in physics, we're talking about vectors in X, Y, and Z. And yeah, they can represent a whole lot of different things, like acceleration, velocity.
What your reaction, I think, is also implying there is that the 2 parameters I cited, being temperature and modulus of rigidity, have nothing to do with physics. Is that what you're saying?
No, those are physics. Yeah, but
okay, great. Then don't exclude them.
What I'm specifically talking about involves X, Y, and Z, and a quantity, which is acceleration, right?
I think you better go watch the vids before we talk about this.
Okay, I thought this was pretty basic, but I'll go watch it.
Yeah, you're gonna think that until you watch my videos, and it's possible we will never hear from you again. But hey, I invite you to go and check them out first.
Well, I use vectors all the time. I have to size a gas spring to support a heavy arm to cancel out its torque so that you can grab it with your hand and easily move it into place and lock it in place inside a machine. Things of that nature. I use vectors
Well,
all the time.
that's nice.
So I don't understand why we're not getting further on this level. I guess this is the basic level.
Well, you see, you have to understand the relevance of the videos I present and how they are applicable to the points you think you're trying to make.
Okay, I'll watch them. No hard feelings. I'll watch them. But
that's awesome, dude.
Yeah. In the meantime, I guess I'll go back to my original point which was that, yeah, you can to what you were saying, Brian. You can draw circles and call that the solar system, and then you can put little, toys that represent planets and have a general pattern going and say, these things are going to be in this region of my sky. Anybody can do that and predict that with any level of scientific understanding, all the way back to like tribal.
Well, you see, and that's the thing is that it ends up being the same pattern over and over and over again. Like it's really not a prediction as much as it's more like a time.
Post-diction.
No, it's a prediction. I mean, you're studying the general pattern, and
if it happens all the time, is it really a prediction?
Well, yeah.
How?
Just because you've seen it before doesn't mean it's any less of a prediction.
Kind of.
It may be an extremely obvious prediction, and you can call it a post-diction.
Is saying the sun coming up tomorrow's prediction?
Yes, technically.
No, it's an assurance. I mean, it happens. Saying the sun doesn't come up tomorrow, that would be a prediction.
Well, I'm a purist. I take a word and I think about it in terms of what its root meaning, what its basic meaning is. A prediction is something you say is going to happen in the future, even if it is extremely obvious, stupidly obvious.
Well, I get that. I mean, if that's your basic premise on that, I mean, yeah, I mean, if you notice a pattern and you know it's going to happen all the time, and you can say, yeah, it's going to happen this month and we're going to do it again this month. Yeah, we just make a whole calendar of it and do it every month for a year and stuff. I mean, is that, I mean, if you want to call that a
meaningful prediction, making meaningful predictions in science.
Yeah. I mean, you're just noticing patterns. I mean, it's really not a prediction.
But that's not really my point that I was making. I was acknowledging what you were saying by saying that, yes, these things generally happen in our sky in certain regions repeatedly.
Yeah.
And you can do that without any theory at all.
I know.
It's just an observation. So, but what I'm saying is that if you lay out a very, very specific model, not only are these circular paths around the sun, and let's even say that the Earth right there, that little dot I put on the Earth's orbit, the Earth, that point is the thing that's stationary, and everything else is rotating around us, while those other planets, those other dots, are making their rotations around that sun that's going around us, which is a much more complex system. But I will humor it for the time being and say that you have to not only lay it out that way, but you have to then put those circles on a very specific tilt and with a very specific amount of eccentricity. So not perfect circles, but slightly oval and slightly off center. And then you have to also put in place a system where they're going faster on the part of their oval where they're closer to the sun and slower on the part of their oval that's farther away.
That's
put all those things in
I don't need
place.
to do that. That's what you need to do to keep your solar system. They're just lights in the sky that go around an elliptical path, and as they do it, they do little loop-de-loops like a spirograph, man. And that happens
That's
for
what I have to do to keep your solar system, Brian.
No, I don't. No.
it's happening in your sky too.
It is, but we don't think like Venus goes around the sun, and that's how you came up with some ridiculous numbers and stuff.
Do they
All I'm
speed up in
saying
the
is
sky?
that if you have this system that's rotating around the Earth, where the sun is going around us, and all the other planets are going around that sun, going around us, and add in
Well,
all the other details
again,
that I said.
there's the
If
sun.
you
The
use
sun.
that,
Everything is going around the Earth. The Earth is the center, man. The sun and the moon are, smaller and localer. And the stars are up there, and they go around. The sun does the day, the moon, the month, and the stars the year, man. It's a clock.
I know there are at least half a dozen other people in this room that understand what I'm talking about. I honestly, respectfully, I don't think you understand.
Did anybody here say that the planets circle the sun while the sun circles over top of us? Aside from you.
Not as their own belief, no. But
okay, because that's not what's happening. What's happening is everything is circling Polaris, which is in the center. That's what we're saying.
That's what we observe.
Yeah.
Yeah.
Exactly. Yeah. Yes. So I don't know where you're getting the planets circle the sun and the sun circles around us. That's not what anybody is saying.
No one here.
That's what I'm trying to get to. Like, okay, so then why did you bring it up?
Because Alan took a break. I know Alan knows because anyone like Witsit, I think they've directed me to a video called "The Principle."
Tycho Brahe. I think you're talking about the Tycho Brahe.
Tycho Brahe. Yes. Okay, there's somebody who understands. Okay, so there is these ways to explain why the wandering stars do what they do and do their retrograde motion and everything. And that video went through all the varying competing ideas that people have brought to the table over the centuries. So I'm just referring to one of those. I guess it was Tycho Brahe, like you said, who said that the Earth is stationary and then the sun goes around us, and also the other wandering stars, planets, go around that sun as the sun goes around us, creating a curly pattern in the sky, just like you would do with that thing with gears that we played with kids, and you put your pencil in it and it made pretty circles and twirls.
Spirograph.
Yep, spirograph. So that would be one of those explanations.
Dude,
in
that's
that video.
what I said, and you said I didn't know what I was talking about. I don't understand you.
Oh, you understand spirographs. You always understand
Literally
childlike
said
things.
that in my explanation.
That was a jab. I'm sorry. I love you, Brian. Okay, in Christ. So
No
what
homo,
I'm saying is, what I'm saying is that if you take that general model and then you add all the specificity that I mentioned earlier, the tilt of each orbit, and then the change in velocity as they go around their slightly elliptical orbits, if you just make a guess, and let me put it this way. If I observe someone who is adding that much specificity to their solar system model, it would be very interesting to me, because I would say, oh, okay, well, you seem to know a lot about the solar system, or at least you're making very amazing guesses, because when I look up in the sky and I do the trig to tell me where those should be in my perspective on my stationary Earth, they're exactly where you say they are. They're exactly where your model says they are. How can that be if your model means nothing?
But to be fair, you also agree that the other model does the same thing in terms of prediction. You just think it's more complicated, and more complicated doesn't mean false. That.
Yes, true. Yes, exactly. My point, and my original point, was that even if I grant, can you guys still hear me?
Yeah, I'm trying to follow you, John, and I'm having a hard time with it because it sounded like you said you guys think the stars are where they're at, and that's where they're at. I don't know. I lost you, man.
Okay, but I understand what you're saying about Tycho. I don't think anyone, even current geocentrists who still think that the Earth is a globe, even believe in exactly what Tycho put forward. I think they still adhere to a neo-Tychonian or new Tychonian system where everything circles the Earth. I think even in the principle that Robert Sungenis believes that the sun and the moon and all of the stars and all of the quote planets circle Earth. I could be wrong, but it's a neo-Tychonian system, not just what Tycho Brahe put forth.
Yeah, that's what I mean when I mentioned adding the rest of that complexity to the model. So like, yeah,
Okay.
I was starting from Tycho, but then I was saying, yeah, if you added more to it, such as the tilt of the orbit, eccentricity, and so on and so forth, then you would end up with a geocentric model that is extremely good at predicting where things end up in the sky, like down to the arc minute and arc second. And so then if that's the case, then I can imagine this middle ground position where I can say, yes, you guys, hey, I'm a geocentrist, just like you all. But the thing I have to hold on to right now, because there's no avoiding it in my mind, is that there is a solar system out there in exactly the shape that they say it is in, and with planets that are going around that sun that's going around us in exactly the speeds that they say. And it is producing those curly patterns in our sky going around us.
That's the thing.
According,
your speed is based on some mathematical equation that it needs to be to keep your solar system alive.
It's your solar system, right?
No, it's yours. With all these speeds
No.
you're talking about, it's yours.
It's exactly your solar system.
And that's what I'm saying, that it doesn't work with them circling the sun. They have to circle over the Earth, not the sun. It doesn't work.
Well, everything's circling over the Earth in that model. It's just they're circling it in complex ways.
The planets circle around us, and we agree that they're up there. Your system imposed speeds on them, just like they put the sun at a speed 93 million. That was you guys. You're the ones that put all the speeds on everything.
We have a Polaris system.
Yeah, and so like if I convert those speeds to what they would be in a geocentric system, and I make Earth the middle, and it's not moving, then I convert all those speeds over to what they would have to be if it was going around us, and it would pinpoint the location.
Space out there, Jonathan. There's no space. Those aren't planets out there.
Okay, well, let me say you are correct. You're right, but if that's true, then how is it that this model of a solar system that is, 3 billion miles in diameter is going around us? How can that system be so successful at predicting the exact locations of the wandering stars down to the arc minute, arc second?
Because it does it all the time.
Well, all it is observation. We observe the sky and we apply that data to whatever model you want to apply it to.
Yeah, you can.
The
They
data
literally
stays the
predicted this
same, the
stuff
visual
before.
changes.
That's true. They
Sorry.
applied this stuff before the globe. Before they thought it was a globe, they were literally tracking and predicting where the stars would be. They predicted eclipses. Like it has nothing to do
The
with the
solar
fundamentals of
cycle.
like gravity or anything that's making these predictions. It's
They're
just like
doing
they.
this in Babylonian times, 25.
I agree with you.
Bro.
Yeah, the they're
I agree with you.
So then, why are you thinking it's exclusive to make these predictions?
Because they can predict the locations of those things down to the
Dude,
arc minute, arc
we
second.
just refuted that. They used to do the same thing, but they didn't assume a globe. Or what like fundamentals of like these systems that you're saying they're applying are separate? You're saying like because they use the gravitational heliocentric model. Like what is gravity? We don't know. So how can you even use that as evidence?
Well, I'm not focusing on gravity. I'm just looking at if you have a kinematic model of a solar system, 6 billion miles across, going around a stationary Earth. The sun's going around us. The planets are going around it as it goes around us. If you just have that kinematic system, if you just assume all those fine details, the tilts of each orbit and the eccentricities and those velocities, even if you know nothing about or even if you have no interest
What do you
or
mean
theory about
tilts of
gravity
these
whatsoever,
orbits?
it still works.
What do you mean tilts of these orbits? What's tilting here?
And that's also what I'm saying. What I'm saying is they're not going around the sun. You keep saying that the sun is going around us and the planets are going around the sun. That's not how it works. They
You're
follow
right.
the
That's not how it
magnetic
works.
field. They then stop saying that that is our model, because it's not.
I never said it was your model.
You said it to me like
Yeah,
three times.
yeah, you did. You said that if your model has the sun going around this and the planets going around the sun, then that's how you can predict. That's what you have been saying, but that's not our position.
I know that's not your
Yeah,
position.
what's the circumference of this sun orbit? Like
The
just not
circumference
the
of
thing
it?
what we thinking. Yes.
I can't calculate that in my head right away, but the radius of that orbit around us would be 93 million miles on average, roughly.
Okay, that's not what we believe.
I know that's not what you believe.
Okay, but you're factoring that into your model of what we believe, which doesn't work.
I'm describing an intermediate position between flat Earth and globy beliefs.
Well, there really is no intermediate. I mean, here's the thing with that. Whatever the globe.
Yeah, Tycho Brahe, that was intermediate.
Hold on a minute. Whatever the globe guys believe, we pretty much don't believe any of that. All right. We don't think the sun is 93 million miles away. You know, those are lights in the sky. They're not planets. All of your speeds are, stuff you guys imposed on it to keep your solar system going around. This is all your guys' stuff. Those are just lights in the sky, man. And they go around us in a circle. And as they're going around in a circle, they did little loopsy-loops. All right?
Yeah, some of them more than others.
Some of them more than others, I agree. And they do this on a regular pattern. And they were doing this back in the Babylonian times, like 2,500 years ago, noticing this stuff.
They didn't think globe. They didn't think globe either. They're predicting.
Yeah, I know. I have a question about that.
Okay, go ahead.
Did those ancient civilizations predict those locations with the same amount of accuracy that we predict nowadays?
Well, it turns out back in the day, they didn't have much to do. They didn't have Netflix or anything and children or anything like that. So they just sat around with their honey bunnies and stared up the stars and watched what they do. So they got to actually look at the stars and see what they're going to do day after day, year after year, blah, blah, blah. And when it started happening the same, it was like, I think it's going to happen again. Boom, it did. It's like, whoa. And then it did it again and again. It's like, man, I think it's going to happen all the time.
They didn't have like advanced telescopes. So whenever you say like down to the arc second, we can do it now. Like they if they had that stuff, they probably would have been able to. They didn't have like the advanced telescopes we have.
So sorry, Taylor, but yes, the fact of the matter is that not only were they able to do that, but that is how we do it today. We use the cycle that they used, and Cage explained this earlier. But if you go onto NASA's website for eclipses, they tell us that they get their information from a specific individual, and when you look into him, he uses what's called the Saros cycle, which is what was used and created in Babylon.
NASA's a clown show. Why do I have any interest in NASA?
Now,
All right, lads and ladettes, I am headed out for the evening. That concludes our Twitter community space. If you guys want to join the space, put a link here in the chat. We'll see you guys tomorrow. Actually, I'll be doing a Prezi for the checks. We'll be going over Holton ARP's red shifts and blue shifts. So we'll be going over that. And then on Sunday, I'll be going over the history of invariance again. So we'll be going over that. And I found a couple of other things since the presentation on Tuesday. So I'll be adding those to the Sunday Prezi. So if you haven't seen the first rendition of it from the Tuesday episode, catch it on Sunday at 3 p.m. Eastern. And then, of course, we'll be back again on Monday for the Celestial Theodolite update number 23, I think it'll be, or 22. So we'll be doing that this Monday. Those will be returning. And we'll be doing a special eclipse presentation featured from our boy Brian, aka Lamazing. So we'll be taking a look at what he used the application of which he used the celestial theodolite for, and determining the altitude of the sun. Very cool stuff. And then Tuesday will be some sort of presentation or something. So we'll see what happens for the next roundtable. See you guys later in the week.